Over to you, Horst.
Okay, then I guess I'm kind of the guinea pig here. Let me see if this works out fine. I want to share my screen, and so please give me feedback if you can see my presentation fine. So I'm not sure because I have a widescreen monitor. Can you see my presentation fine?
Yeah, I can see it perfect. Yeah.
Okay, that's good. And can you also see myself if I'm waving into the camera? Because I don't see myself anymore.
Yeah, we can see you, Horst, there live.
Okay, yeah. But I guess the slides are more important anyway. And so yeah, that's the main. Yeah, for those of you who are visiting the workshop for the very first time, the idea has always been to have some kind of forum for discussions and some kind of networking event. Because regularly at the conference, you go together, you see a presentation, that's about it. And so we had the idea in Portsmouth in England that people come together and have room for discussion after the presentations. And that's what we did. We had a lot of breakout sessions, which is not possible this time. And especially in my case, and I guess that's true from almost everybody. If you have any further questions, please feel free to reach out to me after my presentation or to send me an email. And if you want to get connected and maybe also participate in this huge research project I'm showing you, just let me know. Because again, in this setting, unfortunately, there's not much time for discussion. And yeah, I have my watch here. So I will make sure that I'm staying in time, 8 minutes, as Trevor said. And then we also have 2 or 3 questions, and that's about it. And what I'm going to present today is just a glimpse of a huge project that started about a year ago or something like that. I was contacted by a researcher from the US, Aaron Michael French, and he was asking me if I would like to participate with him on a project, and which sounded very interesting for me. The idea is to find feasibility factors for blockchain deployments. And the initial idea was also to have a closer look at how blockchain is used in academia. And in the meantime, a lot of projects in this space have been developed. So we decided to open up the view a little bit and not only focus on academia, but more in general, what's important, what are the feasibility criteria for blockchain implementations. And the third researcher with us is Martin Risius, who is currently at the University of Queensland. So the three of us have launched this multi-year project in which we strive to figure out what kind of factors need to be in place to have successful blockchain implementations. And what you can see on the first slide here is some data from a study from Martin. And they figured out that established companies have completely different needs than those that are new in a field. For example, on the left, you can see the top priorities for early stage businesses, starting with software development, business development, and governance. And especially the first one, software development, is much less important for companies who are already established players in the respective fields. On the right side of the screen, you can see what's especially important for advanced companies, which might be service and user experience or growing a user base and those kind of things. But taking it all together, of course, it means that it depends a lot on the company itself, whether or what kind of software engineering applications or software engineering in general, and especially what kind of blockchain applications, because this is our field, they actually need. It's not a one size fits all question. So our big guiding research questions are, first of all, how can we assess feasibility of blockchain applications in the first place? Because feasibility is such a broad and fuzzy term. What does it actually mean? And the second one, we want to match different kinds of feasibility with organizational fit. And of course, the dependent variable in all of these cases would be success of a software deployment or a software development project. And those are the two guiding questions. And I have to add that this project will consist of many research papers being published. And we also have a research in progress paper here at the ECIS conference and also another one at AMSIS. And I think one of them is under review at the ICIS conference. So this is just a teaser, if you like. If you're new to feasibility, then it's important to highlight that there are different kind of dimensions. So it's not one kind of feasibility. And if you search for blockchain and feasibility, there are a couple of papers already coming out, and most of them say how feasible is a blockchain solution, but of course, the different dimensions of feasibility. I'm not going into much detail here. I'm not reading out all those definitions for you. I just included a single one about operational feasibility, which is how well a solution meets identified system requirements. So there is a lot of literature out there for each of those dimensions, but it's not the purpose of this presentation to discuss them all in detail. But it's not only about operational feasibility, it's also about a technical feasibility. Can the solution actually deliver what you want it to deliver? And especially when we're talking about blockchain feasibility, we had the situation of a blockchain hype that was followed by a blockchain winter. In the blockchain hype, everything surrounding blockchain was good and useful and feasible. And in the blockchain winter, blockchain was more or less bad for your business. And so what we are saying, you need a more granular view, and you need to look at technical capabilities of blockchain solutions, and there are many different solutions out there and what they can do for you. And another one is, of course, cultural feasibility. Even if you have a solution in place, does it match with what you actually need or with the company culture that you have in place? Because blockchain can do many things, and I don't need to explain to this audience, but it can also, for example, change a company's structure, or even when you're talking about supply chains, then it can remove intermediaries. So we have some kind of culture in place on how you're used to dealing with others. Then we have a legal feasibility. Even if you have the best blockchain solution in place, it does not mean that it complies with legal standards. And Trevor in the beginning was asking you if you're fine with recording this session, which is something you need to do in Europe because of GDPR requirements. And in a blockchain solution, if you have immutability, you also need to take that into account. And finally, very important, economic feasibility. What are you doing? Does it really bring in any economic value to your company? So does it pay off in the long run? So feasibility is a much more complicated concept than it might be at first sight. And so we came up with some kind of nuanced view, and that's what we call the feasibility prison, meaning you're starting off with some organizational need, and then you are coming up with a blockchain solution. And then we are going to look at it from different angles, meaning we look at it from a technical perspective, from an economic perspective, from a cultural perspective, and so on. I think you get the picture. And most importantly, we also included some kind of time dimension. The idea would be to have a look at the company before they're going to start the implementation process. So what do they actually need? And is it really feasible from the respective perspective? And then we want to find some kind of organizational fit. So how companies, if they implement something, can actually match their needs. And we also want to have a couple of case studies that we analyze. And the final output of every case study will be a successful or an unsuccessful blockchain implementation. And in both cases, we want to find out some contingency factors which made it possible. I mean, in the successful case, we want to find out what kind of factors came into play to come up with a successful result. And if it didn't work out as expected, we also want to identify those contingency factors which contributed to an unsuccessful solution. So what you can see on the final slide is basically our roadmap for future research. And once more, this is a multi-year project. And I also talked to some industry partners, and all of them were very interested in participating. And what we want to do, first of all, we want to identify all important feasibility dimensions. What you've seen on previous slides were just the big structure, and we want to dig a little bit deeper and see how we can find variables that can be used to measure each of those, which brings me to the second point. We want to operationalize feasibility. Peter Drucker once said, if you cannot measure it, you cannot manage it. And so we want to find something, some kind of measurements that we can use to identify where you have some kind of need in the company and what blockchain can contribute to it, and to put it all in numbers. And one major output of this research should be an assessment tool that could help companies to figure out if a blockchain solution is really a good idea for them, and more specifically, what it can contribute in different areas. And as academics, our final goal is to have a couple of case studies which illustrate our approach and how useful or not useful our framework is, and to develop it further in order to provide some value to the industry, but also help other academics to come up with their own research ideas. So that's basically it in a nutshell. And I'm opening the floor now. I think I'm about 9 minutes early, which is good. So I'm opening the floor now for questions, discussions. Any kind of feedback is highly appreciated from my side.
Okay, thank you very much for that fantastic presentation, Hurst. So as Hurst said, we were opening up the floor. So if you'd like to put a comment into the meeting chat, or if you'd like to unmute yourself, please fire ahead.
I'm watching the chat now, but again, this is a small audience, relatively small, so please feel free to unmute yourself and just give me some feedback.
Hi, Horst. Kevin O'Malley. I'm in the class with that Trevor's giving at GMIT. Thanks very much for the presentation. Very, very interesting. Where does the current COVID-19 situation fit into your framework? That to me is an environmental factor. It's not obvious in terms of which criteria that fits into under the feasibility prism.
Yes, that's a very good comment. First of all, COVID actually has delayed our research project for a couple of months. That was the practical impact. So that would be some kind of contingency variable or some kind of environmental feasibility. I'm taking a note here because that's very good. If you have something like that, I would call it environmental feasibility, which we did not really consider. So that's a very good point. Thank you very much.
Look, where I'm coming from on that, I used to work in the coatings industry as a chemist, and the company I worked for was working on a particular type of technology, and it was a very good technology. But as soon as PVC was outlawed, it opened the market overnight. So it was an external factor that drove the technology. It was an environmental factor that drove the technology, not the performance of the technology itself.
So what do you mean with PVC was outlawed? What happened exactly?
PVC is it's a chemical, polyvinyl chloride. It's a chemical that was used in a coating technology, but basically it was outlawed for environmental reasons. Okay.
Okay.
Yeah. So the imposition of that legislation created a market for a new product overnight.
Yeah, so that was legislation, right?
Correct.
Because we included legal feasibility.
Yes, that's in here. But then my question is around COVID-19 and the impact of the COVID-19 situation on the model that you've got here.
Yeah, that would be some kind of contingency variable, but
okay.
That's a very good comment, because I'm just thinking if we could integrate it somehow in one of those 5 feasibility factors we have so far, but it doesn't really fit in here that well. So that's something we might want to consider, extending the framework a little bit so we can account for something that comes out of the blue or something like that. Thank you very much for that.
Okay, no problem.
For that comment.
Again, thank you for the presentation.
Thank you. So I think we have five more minutes left. I started a little bit early. Are there any further comments or feedback?
First, I was just looking on my, I'm using Zotero to keep track of my citations, and there are 4 papers that came up that talk about, do you really need the blockchain? And this is similar to what you're trying to do, because these 4 papers that I'm looking right now, they have created some kind of flow chart, some kind of decision tree where you evaluate whether blockchain is a good choice for your company. And some of them that are being written, they are quite rigorous. They are from academics. One of them is from the industry. So is this something related to what you're trying to do?
That's on a very high level. And one of my co-authors, Martin Risios, was also involved in one of these papers that was published in MS Quarterly Executive. But to the best of my knowledge, all these frameworks, they have only a handful of questions. For example, do you need a trusted third party and things like that? And our idea would be to go into much more detail and to come really up with some kind of assessment tool consisting of dozens or hundreds of criteria that can be used to assess a specific situation. So it's not only 5 or 6 questions in a decision tree, but way more thorough, so to speak. The biggest problem I see at the moment is that blockchain can take so many different kind of shapes, and that you have different kind of technologies, and you have different kind of companies. So we have to see if we can manage to put it all into one assessment tool. But on a very high level, that the answer would be yes, but our goal would be to be much more specific, more like the Kaplan and Norton, the balanced scorecard, something more like that.
I see. Yeah, that's what I would kind of was the next question that I was going to ask. It seems like the process that you're designing sounds like the balanced scorecard for implementation.
Yeah, that would be kind of my vision, but of course I need to talk to my co-authors, because initially our idea was mainly to report what's going to happen in the academic community, but again, we are a little bit slower than many companies out there, or even startups, who come up with their own solutions. So we need to make sure that we are doing something that's not being implemented already, and so we extended our view a little bit. But the balanced scorecard, I think that would be something that you could compare to what we have in mind.
Well, one more last point that I want to make is that it seems that when I was listening to your presentation, that one thing that I have done when I started doing my own research about blockchain adoption, we realized very quickly in the very beginning that we need to make a distinction between the demand versus supply side, because their priorities, their angle, their approach is completely different. And supply side, we consider firms who are contributing. In other words, companies who are developing the software, implementation of the blockchain, etc. And demand side are companies who are going to consume the service. So in my opinion, you may want to start thinking about this kind of distinction between the two of them, because their priorities, their approaches are different. So trying to create a universal framework that works both demand and supply side may be quite challenging.
Yes, I would agree with that, and that's why I think we need, in the end, more publications focusing on different kind of industries. And I think we could end up with a book, but we have not discussed it in that much detail. But with supply and demand, you mean companies offering blockchain solutions, and the demand side would be companies searching for blockchain solutions. And there might be some gap in between, because many companies still do not know what to expect from a blockchain solution. On the other hand, blockchain is a moving target, and we see new features being developed all the time. I guess that's what you mean in a nutshell. I fully agree with you. It's kind of complicated. And in the past, I did some consulting in supply chain management, and we were using a tool that was called QSUM. I'm not sure if any one of you has heard about it, which is basically a standardized, or more or less standardized questionnaire consisting of dozens of questions. And this is something I have in the back of my head as a potential outcome. But of course, we would need to adjust it to different kind of situations and industries and so on. Yeah. Let me check the time for a second. So it's almost 10 minutes past 2, because past 3. I need to make sure that I'm in time, because I wanted to start this workshop with a presentation that is not going to be late. And thank you very much, Theo, and everybody else, and Kevin for your feedback. And I would like to hand over to Trevor to announce the next presentation. Trevor, how would you like to manage this workshop? Are you going to announce each presentation?
Yes. So I'll give a bit of an intro into the paper title, and I'll key it over into the next speaker. Thanks a million, Herth, for that.
Thank you very much.
Pity we had more time to, we were getting into real good conversation there. So,
but once more, the idea is, if anyone is interested, just send me an email.
Yeah,
that's the idea of the workshop. And I'm going to mute myself, and I'm looking forward to the next presentations, because I've seen so many interesting topics and abstracts, and I really appreciate this whole workshop.
Thanks a million, Herth. Thank you. Okay, next up we have David Peterson, and his paper is entitled Automating Governance, Utilizing Blockchain to Enhance the Governance of Business Networks. So I'll hand this over to you, David, and I'll let you commence at your leisure there. Thank you.
Thanks very much, Trevor. So I'll share my screen. Let me see. Can everybody see my screen now? It's a PowerPoint?
Yes, I can see it fine.
Yes.
Okay, fantastic.
Yes, we can see it, David.
Thanks very much. Okay, so to introduce myself, I'm another Queenslander. I heard we have one more on. We have some more on the call. But I've been in Asia in consulting for a long time, and I've been in Strasbourg 2 years. Now I'm in the third year of my PhD, researching governance, especially for business networks. So for my PhD, I'm working on 3 papers. First is a more theoretical one, which I'll cover today, and then I'll talk about what my plans are for the next 2 steps of the process. So a little bit more on that later on. So I'll start with an introduction to what I'm doing, and then I'll talk more about future plans, and really look forward to any feedback, any suggestions from all the attendees. Okay, so I'm tackling governance of business networks, which I'm looking at how blockchain can fit into this area. It can almost mean anything to anybody in terms of how to govern a business network. Let's say a supply chain would be a very good example. So there's lots of different ways of viewing it. Some common definitions are working rules. How do you maintain order, and how do you make sure that transactions are processed and coordinated between the participants? I hope it's smaller and you can read these words. I won't repeat them all. But basically, the idea of governance is how can you have a framework and a set of rules, a set of standards for enforcing orderly processing of transactions through the network. So lots of different ways historically. Transaction cost economics focuses really on contracts. So these are written contracts from a few pages to 2,000 pages and beyond. Then we have the very interesting area of social structures and trust, let's say relational governance. So this is a more self-enforced mechanism rather than a third-party enforcement through the courts, through regulation. This is a self-policing method. And of course, in the supply chain, you have to consider the network theory. So how are the linkages between the nodes on the network enforced? And finally, how does blockchain fit into this? And how can blockchain replace or substitute for various elements of this governance? So is it a matter of substitution or complement being a complement, and to what extent? Okay, so there's a lot of new research going on. I'll mention some of it later. And a lot of it has found that blockchain has the potential to substitute for elements, large or small, of contractual and relational governance. So basically, can the mechanisms of blockchain automate what has been done previously by contract and by social structures and trust? Okay, so there's a lot of interesting articles recently. So people are calling blockchain a governance technology, which can automate coordination. It can be self-monitoring, self-governing, self-enforcing. So is there research going on here in terms of to what extent governance can be automated by blockchain? And this is really what I'm tackling in my study. So there's a lot of elements of blockchain which can help with this. So of course, the big ones are, I'll tackle on the next slide, but the elements of blockchain, to what degree can they be aligned and utilized for this automation of governance functions? So these are 3 interesting papers, I think. I mentioned them here, and I can give the full reference to anybody. A lot of them are new, just coming out or just in pre-publication. So I think it's an area where a lot of research is being done, and probably a lot more publications will be made in this year and in the coming years. So to what after I've been working on this 18 months, let's say, and I see that a lot of attention is being paid to it now. And the framework that I've come up with in my first paper is pretty much finished and just seeing what will be done with it. So I defined the automated governance by blockchain as autonomously protecting the rights of people in processing transactions through a blockchain network. So this involves how will you use blockchain as the method of governance? Does it protect the rights of the participants in the transaction processing? Does it add value? So there's some interesting research about governance can also be a source of inter-firm advantage, encouraging cooperation, incentivizing joint work, and more than a simple exchange. How can blockchain incentivize greater depth of cooperation between the entities? And impartiality is a key incentive, I think, in terms of the blockchain networks that have been around, that have been created for, let's say, consortiums for supply chain, for trade finance. There's lots of different approaches that are being made, and impartiality of the network is an important topic in terms of, will all the participants trust that the governance structure, be it centralized, be it a permissionless or permissioned network, do they trust that all the participants will be treated fairly within this blockchain structure? So these are the kind of factors which come together. And then as a result of these factors, to what level can blockchain substitute for relational governance? So basically, how much do you trust the governance mechanisms of the blockchain so that it can replace the social structures that are traditionally representing trust in network and transactions? And to what degree can it replace contractual governance? So how much of these contracts, the hundreds, thousands of pages of contracts, can be automated, can be codified, can be covered by blockchain smart contracts and the blockchain mechanisms themselves? So the two main elements are the structure of the blockchain. So is it a permissionless, let's say public blockchain, or is it a permissioned private blockchain? And so who controls the governance? Who controls the rights of participation, of transaction submission, of validation and consensus? And secondly, what are the capabilities of the smart contracts for replacing trust or replacing the written contract mechanisms?
Hi, David. Sorry to cut across you there. We've ran up to we're 8 minutes. So is it okay if we open the floor to some questions on that fantastic presentation?
Okay, great. Thanks. Yeah.
No problem. So we'll open the floor there on the presentation there, and if you've any questions, David, that you want to ask the floor, please fire ahead.
Oh, great. So yeah, the next step I'm doing, I'm planning to model this through agent-based modeling, and I also plan to look into smart contracts. So I saw that Professors Carvalho and Karemi are working on the creation of a smart contract artifact as well. So I'll be very interested to hear that presentation later as well. So I think so far the theory, and now I'm leading on to a kind of smart contract validation of how it can do these governance functions, and also to use a agent-based modeling approach of modeling the operation of a blockchain for this purpose.
Okay, thank you, David. So I'll open it up to the floor, and we have about 5 minutes of questions. So if you want to, if anyone in the forum would like to answer a question, please do so.
David, this is Horst speaking. I'm very interested. I'm very interested in how you want to model this with ABM. My first question is, did anybody do this before? Because I know there are a couple of papers out there on blockchain and governance, but I don't know anyone using ABM.
I don't think so. So call it a kamikaze mission. But I think there are papers here I mentioned by Kaligotla and Macau, who do our ABM simulation of a blockchain operation, but that's more focused on the generation of a block, the processing of transactions. I plan more to model the operation of, let's say, a supply chain or the trade finance part of a supply chain. So plenty of people have modeled that as a supply chain exercise, but they haven't considered the blockchain and the governance part of it. So I'm not aware of anyone who has done it.
So you're an expert in ABM?
Well, I wouldn't call myself an expert, but I've been looking into it, and I think what I plan to do is feasible, but I don't underestimate the difficulty of it at the same time.
And which software are you going to use?
I think AnyLogic. So AnyLogic it gives you a lot already. You don't have to code so much. Mm-hmm. Do you think I'm biting off a bit much there?
No, I cannot say that. I've used AnyLogic a little bit. I did some agent-based modeling years ago, but I'm definitely not an expert. But I think that's your USP here, using agent-based modeling for governance, because I see a lot of potential. Is this part of your PhD?
Yes, it is. So for my PhD, I have to deliver 3 papers. So I'm planning this to be the second paper. So I've talked to some professors working on ABM throughout different institutions, and yeah. So I think it will be worthwhile. I don't underestimate the difficulty. If anyone has tried or anything relevant, please let me know, because I do think it will be a challenge.
Hi, David. Ashish here. So,
hi.
Yeah, we tried using ABM to simulate a public blockchain, but the main issue we had was, for example, how do you simulate exchange rate? I don't think it directly relates to your issue, but if you're looking at a public blockchain, it does really impact the usability. So if you're aware of security attacks such as DAO, those are security attacks on smart contracts that exploit different types of incentives that are inherent to a public blockchain. So that may cause you an issue when you try to simulate a public blockchain. Either you have to overly simplify it.
Okay, that's a good point. Thanks. I'll consider that. Yeah. So the paper from Kaligotla and Macau, they built an ABM model of a blockchain, I think, to measure the speed and the capacity of the network, and to see what they expect match the blockchain operation. So that's the closest one I could find, and it's not really focused on the application side. So yeah, there's a lot of things to consider, I think.
Okay, thanks a million for that, David. And I have a few questions myself. I think we'll take those offline though, and if anyone wants to find more information, we'll have the contact addresses, email addresses will be emailed around so people can get in touch. Thanks a million for that presentation, David.
Pleasure, thank you.
Okay, next up we have Pratima Jain. Is Pratima here?
Oh yes, hi everyone.
Hi Pratima, how are you keeping?
Hi,
so the title of your paper is An Agro-Prosumer Community Agricultural Framework for Carbon Sequestration and Trade Using Blockchain Technology. It really sounds fascinating. So we're right bang on time, so you can commence whenever you want, Pratima, if that's okay.
Okay, great. I'll try to share my desktop. Yeah, let me see if you can see my presentation. I can't see myself. Is it visible?
We can see yourself and we can see the presentation, Pratima. Thanks, William.
Okay, great. Okay. Hello, everyone. I'm Pratima from Australia. I'm doing my PhD from Curtin University. I'll be presenting my PhD topic, and I'll be taking you quickly through the background, motivation for my topic, and I'll just cover a few objectives. Maybe I'll just, sorry, is it audible now?
Yeah, no, it was perfect before and we can still hear you, yes.
Oh, okay, great. Yeah, it wasn't much comfortable for me. Anyways, yes, I'll quickly take you towards the motivation and background of my topic, and then I'll just talk about the objectives, and we'll just share the model, which just a general idea of how I'm going to use blockchain model for this framework. So as we as currently the global temperature is a big issue for all of us, and with this rising greenhouse gas emissions, it's a big concern that carbon dioxide, which is a major contributor of greenhouse gas, is constantly climbing up. Across the globe, countries and industries are working and looking for ways to reduce carbon, and also finding ways to sequestrate carbon. Now, maybe if carbon sequestration is a new term for you, I would just like to take you back to your childhood memories. If you remember, we used to, we know this photosynthesis process where the plants have this natural tendency of absorbing atmospheric carbon and turning it into sugar and carbohydrate, which is consumed by microorganisms and makes healthy soil. So this is like a natural phenomena which does occur, but it is not actually capable of capturing all the increased level of carbon dioxide and other greenhouse gases. So this is like a natural phenomena, but not able to take the increased level. Now, there are other methods like forestry, land use management, which act as a sink, which act as a carbon sink. There are also technology-based carbon capture and sequestration methods. For example, there is currently carbon capture and storage process, which is CCS. So it is like, it is based on capturing carbon and storing it through plants or soil, injecting it into the soil and like storing it in plastic or using chemical processes to store it, which require substantial capital investment and also require advanced technology. Now, this carbon farming is like another popular way of capturing carbon, which is like going well everywhere. So instead of farming for harvesting crop, carbon farming is like to absorb as much as carbon possible through growing plants, but just to capture the carbon, not for the crop yield. Now, as like, I think like these methods are either naturally occurring or otherwise require government or companies input and supervision. But as individual, we all have the responsibility to work for this global cause, to reduce greenhouse gases and to reduce the carbon. So for this, I just I was like so much motivated that there should be a framework which must be self-sustainable and which is low cost at the same time, and which motivate each and every individual to contribute in this global cause. So for this, I have this framework which uses agro-presumer. Now, you must be wondering, what is agro-presumer? So pretty much presumer is like who produces and consumes the vegetation and fruits. So agro-presumer is one who produces and consumes vegetation and fruits grown in their own garden, and then sell the surplus one to the interested buyer. Prosumers produces generally considered as high quality because they are homegrown and chemical free. And also with this prosumer production, carbon tokens can be generated depending upon the amount of carbon which is absorbed during vegetation process, and can be traded with industries and other firms. Now, if agro-prosumer community group comes into the place, it has a better value and exposure in the market, and also like it can be described using different prosumer profile and personal motivation. For example, if a prosumer lives in apartment or maybe lives in unit or has a big house, so according to their profile, they can be grouped into different groups and can work out. Now, the advantage of using this prosumer community group is it can reduce the long supply chain work, and thus it adds towards the transparency and sustainability. And also it builds socio-psychological experiences. For example, people can build social relationships and they can earn money. They can also share knowledge, and thus they can work towards the community work, which is very essential these days. Now, my framework is divided into 3 parts. The first is to develop a framework to define and characterize APCGs. For this, the interested prosumers' profiles are collected and analyzed based on their conditions, and then these prosumers are clustered into different groups, and their unique characteristics are identified, and those characteristics will be their qualification criteria. For next, it's like developing a framework to recruit new prosumers. So for example, if new prosumers wants to join this framework, their historic data will be utilized to analyze whether they can fit into group A, B, C, D, whatever group we have. So based on their historic data, they can be a part of predefined groups. Now, if a prosumer is very new and doesn't have any historic data, then they will be like evaluated. They will be observed for a certain period of time, and then accordingly they will be fit into one of the groups. The third objective is to develop a framework to manage multiple goals of community based on network. So this is about, like I said, that prosumer groups have, they can sell their goods, they can also trade the carbon. So they have multiple goals, and they can, the multiple goals can be assessed and prioritized depending upon which is the important goal at the moment. For example, if it's the production summertime, so like the summer produces can be prioritized. So likewise, this is about the mutual goal and managing the goals for the framework. So this is pretty much the blockchain model, which it's just a general idea of using smart contracting. So I don't know if you have heard about this. Like in Australia, it happened a few months back. There was a needle found in strawberries, and due to which the supermarket called out all the consumers to return their strawberries, which was a huge loss, and also it was a big concern, health concern for everyone. So yeah, I thought this. Sorry.
Hi Pratima. Yeah, I'm just to leave some time for Q&A. Is it okay if we stop here and ask a few questions, or if there's any questions you would like to ask the audience, please fire ahead.
Oh yeah, sure. So yeah, like using smart contract is what I'm planning, but yeah, would be happy to get some feedback or suggestions, like what are your views and suggestions. Thank you.
Okay, thank you, and I'll leave it open to the audience now to ask a few questions. Thank you, Pratima.
Oh, Pratima, here's Horst speaking again. I've got a question. because carbon trading is something that's not new, it's happening already. So the idea is to put it all on blockchain and to make it easier, right? And to make it traceable. Huh?
Yeah, like idea is like to, the basic idea is to create this framework, like a prosumer framework, so that like collectively the carbon tokens can be exchanged. Because right now prosumer concept is there in the market. This carbon farming is also there in the market, but using this framework of prosumers and then using blockchain is something I'm interested in.
Mm-hmm. But couldn't the trading be done without a smart contract, just having tokens and trade them?
Yeah, like, but I mean, the carbon farming is happening, but it requires some sort of motivation, for example. Mm-hmm. But here it's like, because at the moment, like eating local food is something which is gaining interest. And also like there is supply chain solutions going with the blockchain. So pretty much this project combines so many stuff together. For example, it combines reducing supply chain work. It's also combining carbon tokens. It's combining earning for the prosumers through, and also eating their own grown food, which is like more trustable. And so it's like it's consolidating like traceability and also transparency, and also reducing emission at the same time.
Mm-hmm. Oh, so I understand you need this enhanced functionality of smart contracts to implement all the things you just mentioned. Did you already mention on which platform are you going to make a proof of concept then? I think that's what you mentioned, huh?
Yeah, the framework, yeah.
Is it going to be on Ethereum?
Yeah, Ethereum, yes.
Okay, thank you.
Okay, thank you.
It's very interesting.
Thanks.
Okay, has anyone any more questions?
Sorry,
I have
Trevor.
a question.
Sorry, work away, Trevor.
Sorry,
I'll come in after you.
Yeah. Just a quick one. This is part of PhD research, is it?
Yes. Yeah.
Yeah. So, as Hurst was alluding to there, it would be important to give a robust justification as to why the blockchain or smart contracts would be needed in this scenario, rather than traditional solutions. But it's fantastic work, and I look forward to see the proof of concept there. But I'll hand it over now to Kevin. I think he had a question.
Yeah, sure.
Thanks, Trevor. Pratima, just perhaps this is a very naive question. You're looking at, let's say, inputs and outputs in terms of the carbon dioxide. Is it possible to use the tool that you're developing as a mechanism to calculate the individual carbon footprint of an individual?
Yeah, like using this model?
Yes.
Okay. No, I didn't think about using this to calculate individual carbon footprint, but I think there is a company in Australia which does this. They calculate the carbon footprint and carbon token as well. Yeah.
Okay. If you don't mind, what I'll do is I'll reach out to you on LinkedIn and get that connection, because I'd be interested in pursuing that.
Sure. Thank you.
Okay. Thank you. Thank you.
Okay.
Trevor.
Thank you, Kevin. Thank you, Pratima. That's a fantastic and timely research that you're doing, and I can see from your clock in the background it's quite late there, so it's a fantastic presentation at this time. So thank you, Pratima, and we'll introduce our next speaker now as well. Okay, so our next speaker is from Limerick, and it's Ashish, and he will be presenting on artificial intelligence being used in conjunction with Bitcoin technology and the prediction of Bitcoin. So Ashish, are you ready to go? Hello, Ashish. Okay. I'll try once again. So Ashish, are you there?
Hi, Trevor. Can you see my screen?
Okay. No, I can't see your screen at the moment, Ashish. So now something's happening. Yes, and I can see myself. And if you, yeah,
coming through
perfect.
now.
I can see it. We can see it now. Perfect.
Okay. So I'll change it to full screen mode. All right. Hi, everyone. My name is Ashish. I'm a PhD student at the University of Limerick. I'm also a visiting researcher at the University of California, Berkeley. In this presentation, I'm going to talk about Kian's FYP research project that Dr. Farshid Tusi and I co-supervised. So before I dive deep into nuts and bolts of the ML approach to price prediction, I'll briefly talk about why we are looking at the price and describe the study design first. So the price or exchange rate of Bitcoin and similar cryptocurrencies is often blamed for the lack of widespread adoption as it's highly volatile. However, there's another potential implication of this exchange rate. The security of proof of work-based blockchain heavily relies on the incentives for honest behavior and also punishment for malicious behavior. However, the incentive for honest behavior is in the form of native cryptocurrency of the platform. This cryptocurrency, again, gets its real world value from the exchange rate to a fiat currency. A very low exchange rate may prove detrimental to the network as it can severely harm the incentive in place for good behavior. Last year, we published an article in Computers and Security that looks at this issue in depth and examines how exchange rate can impact security of Bitcoin. It is really hard to evaluate security properties of a large-scale distributed system. So the literature tends to simplify the problem and present it as a Markov scheme of often just two players. Now, this simplification of a multidimensional problem into a game theoretical model of one honest miner and one attacker has its downsides as well. Again, this was basis of our security analysis. However, as pointed out by Sarah Azuri from UCL, embedding incentives in such a simplified model is inherently prone to unrealistic results. One example of this is the selfish mining attack. Now, in a simplified game theoretical model, multiple studies have proved that such an attack is possible and in fact is profitable. But however, we have not really seen a real world example of a selfish mining attack. In this study, we aim to take a step back from simplified game theoretical models and generate a more complex interaction between multiple different types of agent interacting in a single simulated environment. Since our aim is to look at incentive side of these attacks, we need to simulate the reward, exchange value, and incentives. The most common approach, apart from game theoretical model, is to use an agent-based simulation. One notable attempt in doing this is by Coco, where they attempt to replicate the financial environment of Bitcoin using an agent-based simulation. However, the price formulation is primarily based on a very simple supply and demand model that does not really work out in real world. So their predictions are not accurate at all. Another approach to simulating Bitcoin was to use inverse reinforcement learning, where the authors attempted to generate synthetic transactions. Reverse enforcement learning is an example of imitation learning, which is primarily used in robotics. The core idea here is to replicate actions taken by an expert. However, the results from this approach are underwhelming, as real-world Bitcoin network is really complex without set boundaries. So you cannot really use techniques from reinforcement. You cannot really use techniques from robotics. In this study, we try to expand both of these approaches and try to merge them. So the idea is we'll use machine learning techniques, specifically LSTM, a special type of recurrent neural network. This LSTM model interacts with our agent-based simulation to generate a price direction for our model. Kian's FYP project specifically focused on, first of all, finding an appropriate machine learning model that can predict Bitcoin's price with some accuracy, and then gathering enough intrinsic and extrinsic factors and finding their correlation with price. So this diagram shows the overall structure of our project. We have an agent-based simulator developed in Python using Mesa framework with a Flask-based backend and a very simple web interface for users to interact with. This simulator feeds our LSTM model that has already been trained on real-world Bitcoin data with some intrinsic factors such as total number of transactions, the volume, last price, etc. Our LSTM model based on this information will ideally feed back as the next possible price. In next few slides, I'm going to describe the structure of this LSTM model. To recap, the idea here is to first find intrinsic and extrinsic factors that have some correlation with Bitcoin price. After the identification of these factors, we'll do a statistical evaluation, specifically calculate the Pearson's R coefficient for these values to see if they are correlated. And then we intend on identifying a machine learning model for price prediction. And we want to use a per minute basis data rather than per day, because when we are using our simulator, we can easily generate per minute based data and feed it back for more accurate prediction. And using per minute data also allows us to gather a really large amount of data for training purposes. Another thing worth noting when we deal with machine learning models is hyperparameter tuning. To recap, a hyperparameter is a functional parameter that controls the behavior of our model. It usually is a trial and error approach to finding the optimal values. And that's what we see here. So tweak model is basically hyperparameter tuning for any machine learning approach that we might use. Here's a list of some of the factors that we consider. This list includes both intrinsic and extrinsic factors that we considered. You can see that we have some positive and negative correlations in both intrinsic and extrinsic factors. In total, we accumulated well over 1 million data points for a time period of 2 years. We selected the factors that had medium to strong correlation, that is a value of Pearson's R coefficient greater than 0.5. Here's the structure of our machine learning model with 2 layers of LSTM, 1 dropout layer and 1 linear layer for output. The reason why we picked LSTM for prediction is the nature of our data set. It is a time series, and in a time series, the next value depends on the previous value and so on. For this, we need a machine learning model that can remember past data, and this is where a recurrent neural network and specifically LSTM come into play. So here are the results from our analysis. This diagram shows results from an agent-based simulation with just 2 agents, one that follows our model to issue, buy, or sell, and another one that is randomly buying or selling Bitcoins. The red one follows our model and makes a significant profit, whereas the random trader ends up losing all of the Bitcoin over time. We also expand this analysis by including a somewhat strategic agent that will buy and hold the cryptocurrency for a while. Here are the results of all 3 agents that we have. We can see that agent that follows our LSTM model was able to gain 265% in the simulation cycle with the 56.2% accuracy, which is better than the state-of-art LSTM models in Bitcoin price prediction. However, our model also has some limitation. The model only performs well when the price variation is high between 2 time slots. If the price only changes by a small fraction, it cannot predict that well. Another major issue is if you let the model run for a very long period of time, that is a few days, the price prediction changes a lot and in turn loses its accuracy. This is a major limitation in terms of our security analysis, as we had hoped for better price formulation in the longer term. Another limitation is that extrinsic factors tend to have a greater influence than intrinsic factor, thus integrating the model with our security simulator is still very limited. For future work, we would like to explore reinforcement learning more and integrate it with our model to bound the behavior of our simulator in some realistic limitations, such as, for example, an exchange agent in our simulations should not sell out all its Bitcoin to make profit. That's it. Thank you. Any questions?
Okay, thank you, Ashish, and thank you for that fantastic presentation. Ashish and his other authors have presented at our 2 previous conferences or workshops, so it's fantastic to see them back again with this fantastic research. So we have about 6 minutes for questions, so I'll open it up into the forum again to if anyone has any question.
Thank you, Ashish. This is Raghava from Copenhagen Business School. Thanks for the nice presentation. I can see that you're using agent-based modeling and machine learning. My question is, of course, you have this time series data, right? Like, what happens if you try to take the price prediction? You are using only 1 minute prediction interval, right?
Yeah.
But what happens if you, because that gives you a very accurate prediction of the price, because the Bitcoin price doesn't change that often, right? When you say 1 minute, but if you try to increase the interval, what happens in that case?
It stays accurate till a few days. So for 4 to 5 days time period, it does tend to be very accurate. But after that, accuracy tends to drop over time. But it's pretty accurate in a short period of time. I'd say 4 to 5 days.
Okay, yeah. And I have a comment, yeah, but I will wait for if any other people have questions. Okay, my comment is that, yes, we are also working in the similar direction where we have worked in predicting the entities using supervised machine learning algorithms, and where we try to predict the cyber criminal entities in the Bitcoin network using, again, the supervised machine learning. So I think really these kinds of work is very less nowadays in that sense, and really happy to see you going in that direction.
Thanks. So the main idea is after once we have a price prediction model ready, we would use some sort of clustering algorithm on Bitcoin data and define different types of agent that we have in our system, and then integrate these different types of agent into our agent-based simulation and let them interact with each other and see how the incentives play out when compared to real world. That's the end goal of this project.
Okay, very good. And we've about 2 minutes left for questions, if anyone else has a question.
Hi, Ashif. This is Theo. I have a question. How does your research compare to the research that has been done in finance about intraday trading?
In finance, first of all, the prediction, in terms of prediction, the state of art is using LSTM model, and that's exactly what we're doing. But in terms of simulation, even in finance, if you're trying to simulate a stock market, you may be able to reproduce it for a short period of time. But if you let your agents run for a few days, they tend to get far away from reality, because now they are interacting in their own world with their own set of constraints. So it's not realistic to simulate a financial market over a long period of time, and that's exactly what we observed. But in terms of predicting price, we are using LSTM, and that's the main reason why we use LSTM is because it's sort of a norm in traditional financial markets as well.
So you take into account attempts made to take advantage of the market, drive the market in a certain direction?
So if you let the agents run on their own without any realistic data, they tend to, for example, we designed an exchange agent. So the aim of an exchange agent in traditional Bitcoin market would be to receive transaction and then hold them up until the entity who requested the transaction asks you to send them off. But if you try to simulate them over time with the intention of maximizing, they'd end up selling all their assets. This is a very common issue in reinforcement learning, where your agent will try to maximize its profit over a short period of time, and they get very far away from how that agent should act in realistic world. And it's at the end of the day, it's a question about how good your modeling of these agents is, and it's really hard to model a real world agent very well. And that's sort of a limitation that comes with an agent-based modeling approach.
Okay, thanks a million for that, Ashish. And I'm just cognizant of time here. So thanks again for that fantastic presentation. And if anyone has further questions, you can contact Ashish to get further information about this very interesting piece of research. Thanks again.
Thanks, Trevor.
Thank you. So next up, we have Eamon Walsh. Eamon's the head of the Department of Enterprise and Technology here at the Galway Mayo Institute of Technology. And his paper and research he's presenting today is called Academic Credentials on the Blockchain. I'll hand it over to you, Eamon.
Okay, thanks very much, Trevor. And thanks everyone, some great presentations so far. I'll just try and share my presentation here now, and hopefully we can get this to work. Please bear with me a second there now. Okay, can people see the screen there now?
Yes.
All good to go, Eamon? Yeah.
Excellent. All right, great. And I must remember now to turn off my mobile and put it on silent. So that's the last thing I need to do. Thanks very much. Thanks for the introduction, Trevor. And as Trevor mentioned, I'm head of department here at GMIT and also a PhD candidate. Still in the early stages of my PhD. Completing out my literature review at this time, around this time last year. Lucky enough to be in Stockholm at the ECIS conference there with Trevor and others. I know I met some of you there last year, so it's good to meet you again today virtually. At that stage, I was looking into digital identity, which is a real exciting and interesting area to look at, and very much related to what I'm going to talk about just now in terms of academic credentials. And there is a lot of exciting work happening on blockchain projects like Uport and Blockstack and many others in terms of digital identity. So I've no doubt that solutions will start to come forward on that as we go into the future and become more mainstream, and we'll get away from having to manage all of these passwords. But then as I said at that conference, I think, and I was looking to relate it more to my own work and my area of what interests me in terms of managing students. So student identity, I'm sure, will be managed in the blockchain in the future. And then I started to look at the whole idea of how we manage academic credentials and this idea of digital credentials for our degrees, moving away from our traditional parchments and the like. Which have served us well up until this point. But as we go forward, especially given the demands of the modern workforce and the expanding skill set of same, and I really like this image here, which talks to the old school credentials of our major awards like undergraduate and postgraduate degrees and masters and PhDs. While they very much still are part of our of the mix, they're also mixed in with lots and lots of other minor credentials that we pick up along the way throughout our careers. And what you're seeing now is a move to digitalize that content. Much of that learning happens online nowadays, and more so. And this idea of basically credentialing that in a digital way. Digital badges are very much a part of that. And I suppose what my research now is looking into how these all come together under a single entity, if you like a digital CV. So you could think of that like a LinkedIn profile at the moment is very much, has been put together by the user and sits there as a kind of a digital CV of their career, but none of it is certified in any way, or you can't actually prove that any of it has taken place. And that's kind of what we're looking now to. A lot of the research happening in the area of blockchain research is looking into how would you govern that, how would you actually have the digital credentials held on a blockchain so they can be shared and verified, if you like. So I'm just trying to set out then the research problem here. So the current process for digital academic credential issuing, verification and access is not fit for purpose. It's more or less taking an old world process and trying to make it work digitally, and it just doesn't today. There's also a real need to facilitate the formal recognition of non-standard learning, and I've put that in bold because that's a part of that's the area I'd like to do further research on. And then, of course, because it's driven by the demand of the lifelong learning, if you like, for the workforce today and into the future. And this very much came out of the work of Gretchen and Camilleri in their paper for the Joint Research Centre of the European Commission that was published a couple of years back. Also very much about trying to fight academic corruption. So there's lots of good reasons why we would want to do this and use the blockchain to be able to write those records into the block and basically have the immutability of the blockchain and use that to our advantage to try to we've heard of all the diploma mills, etc., that will just provide you with parchments and credentials very quickly in the digital world that can be done literally in seconds. So we need to take steps to combat that. This is just a very a pictorial view of the current process for issuing credentials. The issuing is through academic institutions or other education providers, very much proprietary systems lacking standards or interoperability. Verification of these is cumbersome, complex, inefficient, and sharing manual processes which lack security, PDF documents sent through email. There are some steps to try to secure that, but they're uncoordinated and cumbersome. So we're trying to get away, move away from this to solutions on the blockchain. And as part of my literature review and looking into this, there are certainly several entities and some very smart people around the world working on this problem, and we're also already seeing some very much some solutions that are quite mainstream coming out of the University of Nicosia. Block certs from MIT Media Lab in the States, and a very interesting one from the University of Maribor in Slovenia. All of these on permissioned blockchains. I think the first two are Bitcoin and Maribor, I believe, is Ethereum. And then some interesting research that I found in Japan, although that's a permissioned blockchain, so it's not publicly available. The others are more open source, if you like, and are available to implement on a pilot basis. And I'll talk about that in a second, is what I'd like to do to take this further. Essentially then thinking about the future of what a credentialing ecosystem might look like. So you have that idea of this verifiable LinkedIn or super digital CV, which is shown on the right hand side there. So the student's identity is verified via the blockchain. The issue and the certification of the credentials then are this digital CV, the entire lifelong learning verified for the candidate, and then it meets our regulation and assurance requirements as institutes. It meets the security requirements, and accessibility then and sharing of this can be done in a much more secure way. So just to finalize out on that then, so a lot of these facilities exist, or there are pilots and mainstream applications on the blockchain as we speak. My interest then looks into a particular problem we have in terms of recognizing prior learning. So we would have a lot of students who want to apply to our college, and not any different from other colleges, who have already completed either a program of official study with another education provider, what we might call certified learning, or experiential learning, that they've really gained experience which is very much applicable or equal to a course of study that would allow them advanced entry onto a course or have exemptions from certain modules on a course. So now the certified learning is somewhat easier to assess, still a very manual process. The experiential learning is much more difficult to assess and very, very much a manual process. Just in terms of our own college here at GMIT, we're part of the Connacht Ulster Alliance here. It's as we move, we're actually in the process of moving to become a technological university in partnership with Sligo IT and Letterkenny IT here in the west of Ireland. And we have a system and a website called myexperience.ie, where we're trying to use e-portfolios to help with this recognition of prior learning facility that we want to provide to students. But it's very, very much a manual process. So final slide, what I'm hoping to do for the next phase of my PhD is adopt a design-based science approach, to take one of the pilot open source pilot projects that I mentioned earlier, and implement that on a pilot basis at GMIT. And then looking at, so you have a digital CV for a candidate who wants to apply for a course, and then using smart contracts to essentially try to map this to learning outcomes of or the syllabi of modules on our programs, and then try to come up with an indicative match. So for example, this particular candidate here has a lot of the skills to meet the learning outcomes of this particular module, and you get some kind of figure which can automate or semi-automate the recognition of prior learning tasks. So that would be, if you like, my contribution to knowledge in terms of taking a lot of the great work that's happening already in academic credentialing using blockchain to take it a step further, if you like. So very exciting for me, and I'm kind of getting towards the end of my literature review now and starting to map out the frameworks on how I bring it the rest of the way. And yeah, that's a challenge, but one I'm really looking forward to. So that's it for me. I hope I'm doing okay on time there, and take a few questions if anybody has any or comments.
Okay, thanks a million for that, Eamon. We have about two and a half minutes for questions, so I'll open up the floor, and if anyone wants to ask Eamon a question, please do so.
Oh, thank you, Eamon. This is Horst speaking again. So,
Hi, Horst.
This is really interesting stuff that you're doing. I just wanted to point out that we at our university are now implementing such a system, and I will send you the link via email. It's called Sproof. It's not one of those which you mentioned. Yeah. And I find the one slide which you have on the screen right now very interesting. So what you're saying here is that you're running some smart contracts, and what you get out is a number that indicates the fit of a candidate.
That's correct. Yeah, that's the plan. That's what we'd like to do. So it will mean we haven't done this yet. This is what I propose. That we take some of and you're right. And I should have said earlier that it's not an exhaustive list. It's just the a highlights of the better ones that I've found out there.
Yeah, I know
there are more.
Yeah, yes.
Yeah, so please do send on the links to me. I'd be excited to see that. But yes, so the idea would be to actually write and develop smart contracts that would attempt to do something like this, to do this matching between the digital CV and our own syllabi and learning outcomes to come up with a match on, can we give this student an exemption from this module if they joined our course?
Yeah, because I'm part of a committee, a data privacy committee, and I recently learned about a couple of cases in which students who were not admitted to a university filed some legal suits because they felt to be unfairly treated. And I'm just wondering what's going to happen if we outsource such decisions to, let's say, technology. And if technology says that you're not eligible for a program, and what's going to happen in the legal sector if many people are going to sue technology, and this might be interesting. What's the outcome?
That's a great point. I mean, this is almost sort of machine learning type of research as well. It's touching into that. I think it would need some oversight. So that can be checked before, say, students are literally just told by a robot that no, you can't apply.
Yeah, actually, I know the story of a CEO who based his decisions on astrology, And of course, they never made it. They never. No, that's a true story. But of course, they never made it public. But I was given this inside information. And of course, if you're using a smart contract, it's much more visible because you need to justify it. And I'm really curious what's going to happen if you have some legal issues. But it's a very interesting topic and very relevant what you're doing.
Thank you.
Okay, thanks a million for that, Hurst. And I see we're moving on to the next presenter. If you want to ask Eamon any questions at all, please do so in the meeting chat room, and you can take it also offline. And I'd like to thank Eamon for that fantastic presentation there. And hopefully we'll see more fantastic progression also next year on it as well. Okay, so next up we have Tim. And Tim and his colleagues will be presenting on design principles from the NutriSafe project.
Yes, thank you very much. Can you hear me?
Yeah, we can hear you, Tim.
Okay, that's nice. Now I'm trying to share my screen. Is it working?
That's perfect.
Okay, nice. So thank you very much. I'm really happy that I can present today some insights and results in our research project, NutriSafe. My name is Tim Heust. I'm a PhD student at the University of the Bundeswehr in Munich, Germany. And the topic is today the design of blockchain-based information systems. It's a collaborative effort of some of our partners, which are listed below in the research project. And the main goal of the presentation is to get some feedback from such an expert audience today. That would be really great. So what is the NutriSafe research project? It's a bilateral project between Austria and Germany. And its main topic is the exploration of the blockchain as a technical infrastructure to increase resilience in food logistics and production. It's founded by the German Ministry of Education and Research and the Austrian Federal Ministry of Climate Protection, Environment, Energy, Mobility, Innovation and Technology. It's containing of 14 partners in Austria and Germany, and some of them you can see on the left side on the pictures. And yeah, we have expertise in various domains. So we have partners in from logistics, from legal matters, from food production. One farmer is part of the project, and as well as governmental authorities and IT security experts. On the left side, you can see one result in our project. This one is called the NutriSafe demonstrator. It's built with Lego and animation behind it, where you can actually interact with the blockchain. You can get the role as a producer and go to a website and register you, and you are then part of the supply chain. And you can also interact with the legal model and disrupt the supply chain and see what happens. And yeah, it's really cool project. So today, it's about our guiding scenarios and the design principles which resulted from them. We have 4 of them. The first is the urban consumer that demands information not only about the nutrition of food, as well as about the whole supply chain, that he gets some transparency of it. Where the food was produced, where it was transported, where it was transformed, and so on. The second one is a typical crisis situation, for example, a cyber attack with ransomware or something like this. The third is more about food safety issue. It's about recalls and traceability of the food products. We're having a look into how make it more, or the recall, we can increase the speed of the recall and increase the efficiency of it. Because today, a lot of the process is paper-based, and you have to call the next part in the supply chain, and we're having a look into that, how we can increase it with blockchain technology. And the last one is a major crisis where public authorities need to step in and manually distribute the food or resources in a region or country. So in these, or with these guiding scenarios, we actually developed blockchain solution based on Hyperledger Fabric. And the first thing was more an observation we had, and that it is not simple to build a blockchain-based information system. We had several, the technology stack is really deep if you want to go from really low on the network operation side to the end consumer or the actual user of the network. And it needs a lot of knowledge to build something like this. Since I don't have that much time today, I will only pick one out of these design principles. All of them are explored a little bit in the submission. So the point I want to speak about is the transparency versus confidentiality issue. In general, public blockchains, most of them are fully transparent, and there are some techniques how to get some confidentiality, like zero knowledge proofs and so on. But the main assumption is that the blockchain is wholly transparent. And we learned in our experience with some discussions with partners that, and as well in the study, that some organizations have a fear that the open information in the blockchain can be used against them by competitors or malicious actors. So one principle we followed is that we make use of fine-grained confidential techniques depending on the application domain and the use case. Specific, we are using Hyperledger Fabric, and there we are providing a channel structure, and you make use of private data collections, maybe in some time of the identity mixer and the attribute-based encryption. So the next few principles are or aspects. They are not providing every solution. That's only points I think we have to speak about if we want to build a blockchain-based information system. They're about governance and ecosystem. And there I picked one special one, the specific versus global. In the beginning of the project, we were thinking about one big blockchain network and every information is going in. So then we learned that we don't need this big network for every use case. And it makes sense to actually do small-scale specific blockchains, for example, for regional food safety use cases. And for other use cases or applications, we need larger blockchain networks. For this, especially for food security, because in the food security incident or in the food security use case, the public authorities need a lot of information from a lot of sites and organizations, like resource capacities and actual products of food which they have at the moment. So they can step in and direct some of it. Yes. So that's it about the NutriSafe project and the design principles. So I'm happy to get some feedback from you about those.
Okay, thank you, Tim. Fantastic presentation there. Really interested in the complexities of actually developing a blockchain IS system and your experiences of the Hyperledger Fabric. So what I'm going to do is we have, because you're just under time, we have a good bit for questions. If I'll throw it out there to the forum.
Mm-hmm.
Tim, this is Horst speaking again. I'm always waiting if somebody has some questions. I have to say, Trevor and I are now editing a book on blockchain use cases, and I'm really sorry that many of those papers we have seen today were not submitted 1 year earlier or so to our book, because it's really interesting what you're doing. And just during your presentation and also in your abstract, you mentioned urban consumers. So what I'm doing now, I'm posting in the chat a little bit of advertising for a special issue that Trevor and I are are doing for the journal Smart Cities. It's an open access journal, but you have to pay for it. But if anyone today is interested in submitting a papers, we can also give you a voucher that makes it a little bit more cheaper for you to publish there, because we now have an extended deadline until the end of September, and I could also see your paper in there, just in case you're interested, if you want to publish some of your research out there. But to wrap it up, this is something that's going to happen. You're building a real-world project here, right?
Yes. So we started and we developed the blockchain network of Hyperledger Fabric for now. We are just going over the chain code and smart contracts we developed and making them a little bit better, I think. And we are looking to one of our, maybe more of our praxis or civilian partners to go outside and make or evaluate the solution. And for that, we have to actually develop a lot of parts, not only blockchain, also the user interface and the connectors and so on and so on. A lot of them still already stands, but there's some work to do yet.
Yeah, and what I like, you're making everything transparent. You're publishing the
Yes.
results and the evaluations, and also the source code. Is it also open access?
Yeah, it will be all open. For now, it's on. It will be all on GitHub at some time. But yeah, we want to publish everything. We have a website where all the results are getting published. It's in German, I think, so it's sometimes difficult. But we want also to publish the design principles we presented today, at least as a working paper.
Because I know many big, especially big companies, they are experimenting with blockchain in the supply chain network, but of course all of that happens behind closed doors, so it's not clear what actually they are doing and how it works out. So projects like yours are highly appreciated because it gives a lot of transparency to the space. And yeah, I assume you're also going to report all those obstacles and challenges you needed to overcome, and if something's not working out as expected, right?
Yeah, it happens a lot that something is not working as expected. Yeah, but we saw that too, that there are some projects going on, like IBM Food Trust and TradeLens and so on, but they are not publishing a lot how they actually do it and how they distribute the power in a decentralized network. A lot of them are holding it, and we are trying to actually establish something where the network is fully decentralized between several organizations or authorities.
Yeah, great. I just bookmarked your website.
Okay, nice. Thanks.
Thank you.
Okay, thank you, Hurst. We have about 2 minutes left for any further questions if anyone would like to ask. I have a question, Tim, if that's okay.
Yeah, sure.
A lot of people advocate the use of blockchain technologies, you know, and they jump right into the water with them. You've been through the process. Is it really, are the complexities really fundamentally hard around developing a potential use case like this?
Yeah, it's we started in the beginning, and we also thought, okay, how hard can it be to develop a blockchain network on a framework like Hyperledger Fabric? It was just released in the 1.0 version then, and a lot of happened since then. So the documentation in the beginning was really hard to do something, and we are jumping from one era to the next era after finally understanding how it works. And then there were a lot of new technologies we need to learn to actually get it out of our test network and to interact with some companies and so on, to show them, because it's not really nice if you can go to a terminal or command line interface and hit some buttons and something happens there that might be interesting for someone who is deep inside these technologies, but not for a logistics company or farmer.
Okay. So Yeah, thanks for that, Tim. It's great to have a presentation where someone's been through the design principle process, and I look forward to looking at your code on GitHub and reading that design paper when it does come out. And thanks again for presenting. And if anyone has any further questions, you can get in touch offline with Tim and the fellow authors. Thanks again, Tim.
Thanks.
Okay, next up we have Arthur, and his paper or research is called How Blockchain Can Bring Trust and Transparency to the Payment of Crowd Forecasters. So I leave it over to you, Arthur.
Thank you, Trevor. Let me try to share my screen now. Let me see here. Can you see my presentation now?
Yeah, yes, I can see it, Arthur. Perfect.
Awesome. So welcome to my presentation. My name is Arthur Carvalho, and that's a joint work with Majid. I am at Farmer School of Business, Miami University of Ohio, and Majid is at California State University, San Marcos. Our work is about how blockchain can bring trust and transparency to the payment of crowd forecasters. So our work is really applied in nature. Just to give you some background information, crowdsourcing platforms like Amazon Mechanical Turk and Figure 8, they allow us, anyone, to hire thousands of people all over the world. And one specific task is becoming more and more common inside these platforms, which is the crowdsourcing of forecasts. Just to give you one specific example, think about this question I have in my screen now, which is a real life question posted on the Good Judgment Project, which is a crowdsourcing platform. The question asks which presidential candidate will win Pennsylvania, and then any person can go online and report a forecast. For example, my forecast here is 75% will be the Democratic person, 25% will be the Republican candidate. We're interested in our work in settings where the forecaster is hired to report a forecast, and eventually the forecaster will receive a payment in return. That payment is dependent on the quality of the proposed forecast. And by quality here, I mean it depends on how accurate the forecast is, or how good the forecast is in predicting the events of interest. The problem now is when you measure the accuracy of a forecast, you need a realized outcome. And that realized outcome will only happen in the future. So if we go back to the election scenario I discussed before, we have to wait until the end of the election to see the candidate who won the election and eventually measure the accuracy of the forecast. As a consequence, the forecaster only receives money in the future, so the payment is only issued in the future. And that is a tremendous issue in crowdsourcing settings, because by nature, labor and contract laws are very weak in crowdsourcing platforms like Amazon Mechanical Turk. We have come across situations where requesters asked for a forecast, and eventually after receiving the forecast, they did not pay the forecaster, mentioning that the forecast was just random or carelessly reported. So what we want to do is to avoid situations, to make sure that a forecaster receives a payment once a forecast is reported. So we base our solution on smart contracts and blockchains. So I'm going to now explain how our solution looks like. It's just a bird's eye perspective of our solution to the previous problem. So the main point about our solution is we will develop a contract between a requester and a forecaster. That contract is coded as a smart contract. The smart contract is a bit long. I have just the main points on my screen now, but inside the smart contracts, we have the requester's address in the blockchain, which is the requester's ID. We have the forecaster's address as well, so we know who is requesting and who is reporting. We also have the payment scheme that's used to evaluate the forecast. So now the forecaster knows how his money or her money will be defined, will be calculated. We also have the source of truth. We have to somehow retrieve the realized outcome. Within the blockchain context, these truths are called oracles. So the oracle is well defined inside our smart contracts as well. So now both the requester and the forecaster, they know where the realized outcome will come from. We have two other points in our smart contracts as well, which is the deadline for the forecaster to submit a forecast and the date after which the realized outcome is available. So these are the main attributes in our smart contract, and all of them are publicly viewable. Now I'm going to go through the steps that the requester and the forecaster will go through when using our solution. So the step number one, we have the requester developing the smart contracts and posting the smart contracts on the blockchain. Together with the smart contracts, the requester must fund the smart contracts, must send some money to the smart contracts. At this point, the smart contracts behaves as an escrow account. So the smart contracts now has enough money to pay the forecaster, no matter how accurate the forecast is reported by the forecaster. So that will be the step number one. Once the smart contract is deployed, eventually the forecaster in the future can submit a forecast. The smart contracts will receive a forecast, will check if whether all the probability values are good, if they're between 0 and 1 and they sum to 1, whether the forecast was reported before the reporting deadline, and so on. So if the forecast is acceptable, if all these conditions are satisfied, we can eventually in the future call the blockchain again, call the smart contracts, and request the smart contracts to retrieve the realized outcome. We can have either the requester or the forecaster initiating that process, initiating that request. So whenever I say Oracle here in our work, in our presentation, that's just an API endpoint. Inside our smart contracts, that's just one URL pointing to some website. So eventually the blockchain, after the request, the blockchain will talk to the Oracle and retrieve the realized outcome. The step number 4, the last step, is now either the requester or the forecaster can ask the smart contracts to release the money. So the forecaster will get some money based on the reported forecast, the realized outcome, and the payment function inside the smart contract, and the requester will get the leftover, the escrow money minus any payments issued to the forecaster. So that is a bird's eye perspective of our solution. We argue that our solution boosts trust because the forecaster is always paid. As soon as the forecaster reports the forecast, from that point on, there's no way for the requester to avoid a payment. And perhaps the most important point here is that contracts enforcement is automated. So that is the basic premise behind smart contracts, in that we can force a certain contracts to be enforced, if you will. The second bullet point says it boosts transparency. So our work, we argue that it boosts transparency because payment scheme is really well defined within a smart contract, plus the source of the realized outcome is unambiguous. Both the requester and the forecaster now know where the realized outcome will come from. So just to explain now the current status of our work and finish my presentation with some open questions. In our current status now, we have a full prototype up and running. We developed a smart contract using Solidity. We developed a user interface that will interact with Ethereum, the blockchain we deployed the smart contracts to. Throughout our working paper, we use design science, the classic paper by Peffers, to guide our the development of our system. In terms of theoretical background, we are using a one specific news vendor model to kind of provide some theoretical background for our work. Just to finish my presentation now, I might be running out of time in a few seconds, but I have 5 open questions that we are hopefully we're willing to get some feedback, and hopefully we'll get some feedback from you. Number 1 is how to evaluate our work. Any ideas how to evaluate our system? Number 2, what would be the most appropriate theoretical background? We thought about news vendor and principal agent model. Number 3, what would be perhaps the most appropriate design science research framework to follow? Number 4, which angle should we explore? In my presentation now, I'm talking about crowdsourcing. In our working paper, we have changed to supply chain risk management. And number 5, what are the potential issues that you can see with our solution? And with that, I'm going to end my presentation. My contact information is there, my LinkedIn as well. So please feel free to stay in touch.
Okay, thank you, Arthur. We have about 6 minutes for questions. Arthur has presented really good, cogent, 5 cogent questions there. And if anyone can be of assistance, I'll open the floor up for questions.
Arthur, this is Theo, and I have a question. And it's not a question, it's a clarification. Could you use the example of the opening slide to explain the logic of your approach?
Absolutely. So let me go all the way back to that example right here. I'm not sure if you can still see my screen now.
Yes.
Perfect. So let's say that you and me, we are somehow, I'm the requester and you are the forecaster. So the very first step is I will develop a smart contract. In that smart contract, I have your blockchain address, I have my blockchain address, and I have an URL that will specify the winner of the election down in the future. So all these attributes are stored there. So as the requester, I will post my smart contracts on the blockchain. Now, instead of going to a web interface like you have here, you will go to some well-developed interface where you will actually provide a forecast as well. That forecast will be stored in the blockchain, through the smart contract. Now we have the forecast is stored in the blockchain. Eventually, we can see the observed outcome in the future, the realized outcome, and you can ask the smart contract to issue a payment based on the forecast that you reported before. The only difference I would say is primarily the background technology. We could have an interface like I have in my screen now, but that interface will be talking to the blockchain, and eventually that interface will allow either the requester or the forecaster to retrieve the realized outcome and to ask the smart contracts to issue payments as well.
So in a case like this, the oracle will be the decision that was after the November 3?
Precisely. That's precisely what it is. Because the thing is, how do we know which candidates won the election here? We have to somehow specify the source of truth. It cannot really be you or me, because we can manipulate the outcome. I can say something and you can say something else. Now we have to agree somehow on one specific API or one specific endpoint that will tell us that is the candidate that won the election. And that's pretty much one URL. That URL will say that, for example, candidate X or candidate Y was the winner of the election.
Okay, have we any further questions?
Hi, Arthur. My name is Kevin. Can I ask a very, very naive question here?
Absolutely.
Why use blockchain rather than just a centralized database?
That's an excellent question. The whole idea here is we want to avoid potential manipulations. So if you have a centralized database, that can in theory be manipulated somehow. Or we can even think about the Good Judgment project that I have in my screen, or Amazon Mechanical Turk. These are proprietary platforms. Even in these proprietary platforms, things can be manipulated. For example, as it happens right now, inside Amazon Mechanical Turk, if you submit a forecast, I can always say that your forecast is no good and avoid paying you. And that's it. You cannot really sue me. There's no problem there. Using a blockchain platform, we can automate the whole thing with smart contracts.
I worked in a business that uses the crowdsourced model. It was I won't say the name of the company, but basically it's one of the large search engines. Let's put it that way. And again, the questions, the majority of the questions coming in from potential crowd workers was around payment and sort of ambiguity within that whole structure. But what you're suggesting there takes that whole debate away, because it's completely transparent.
Precisely. And that was one of the questions I faced as well. When I was a PhD student years ago, I was working with forecasting, and I actually crowdsourced the forecast task. And most of the people on Amazon Mechanical Turk, they just reported 50-50, like kind of a careless forecast. And I was annoyed to a certain degree because I had this bunch of flip it coin kind of answers. But what my PhD supervisor said at that point in time is, Arthur, that's perfectly valid. I mean, that's not, you have to pay them regardless of what they reported. So in theory, I could just stop and say, I'm not going to pay you because whatever reason I have, I would be allowed to do it with no consequences whatsoever. And that's what we want to prevent here. We want to make sure that even if you have a poor answer to a question, you still get paid.
What you'll address there will be the recruitment and the churn of the people that participate in the program, because that's where the major cost is. Sorry, Trevor, I'm taking up too much time.
That's fantastic. It's been a fantastic presentation, and I'm sure there's a variety of questions, and Arthur put up 5 really strong questions there. So if anyone would like to get in touch with Arthur, please do so, because there's really some good questions there that would help Arthur out. Thanks again, Arthur, for this presentation, and it was really good. So next up we have Christoph, and Christoph's paper is entitled A Decision Path for Blockchain Design, a review of the interdependent properties of blockchain and Bitcoin. I'll leave it over to you, Christoph.
Thank you, Trevor. Hi, everyone. Thanks very much for all the great presentations. So my name is, can you see the presentation now?
Yes, we can see yourself, and we can see a white screen at the moment.
Full white?
Yeah, full white, full white.
Oh, that's not good. Wait.
Yeah, I can see it now. Yeah.
One minute. Sorry for that. Is still widescreen now?
Something's happening here. Yeah, it's still a white screen.
Oh gosh. Okay, never mind.
We could see some slides a couple of minutes ago in terms of it wasn't in full presentation mode. Maybe if you take it out of presentation mode.
Okay, sorry. Is it now?
Yeah, we can see.
Okay.
We can see. Yeah, we can see your slide.
Right? Okay,
perfect.
great.
Yeah,
okay.
Perfect.
So my name is Christoph. I'm a DBA student at City University, Hong Kong, and I'm based in Thailand. So the theme is Decision Path for Blockchain Design and review of interdependent properties of blockchain and Bitcoin. So we start from the real-world problem, which is that organizations at large are increasingly interested to adopt the blockchain technology. Several reasons for that, of course, improving process and business models, especially when TTP is involved. But organizations tend to have a limited knowledge about the technology, and is somehow difficult for them to actually select the right solution, and at the same time being even part of the design of the solution. So for the research, we will focus as on Bitcoin, as it is recognized the first real-world example of blockchain technology use, to study the Bitcoin properties and mechanisms, and to see how blockchain technology contributed to those mechanisms, and to understand from there the benefits for the organization to adopt blockchain technology. So the expected result would be creating a decision path, proposing a matching between business context objectives and blockchain technology properties and benefits to support organization. A possible application or focus would be on operation and supply chain management. A second part of this research is starting from an area of concern, which is Bitcoin is recognized in the literature as the most prominent blockchain application. At the same time, in the literature, the features of Bitcoin and blockchain are somehow intertwined, and there is still no existing consensual definition of blockchain. So the research will start from the analysis of Bitcoin protocol and to see how Nakamoto managed to combine prior research on some technologies and add up some innovative mechanisms to create the Bitcoin system. At the same time, we review the literature from 2014 and the first article mentioning the word blockchain, and to review how the literature actually display the different properties and mechanism of the blockchain technology. So the expected result would be a mapping of the Bitcoin blockchain technology respective properties and mechanisms, and stressing their interdependence, and at the same time try to define blockchain technology. The research objectives, so it's 3 points. First, to clarify how much Bitcoin protocol relies on blockchain technology and how much it is different. So it's ready to create the different layers of technology inside the Bitcoin protocol and see how blockchain technology contributes. Combining the number 2, combining the template provided by the Bitcoin protocol, how it integrate blockchain technology in it, and to compare with the what the literature review actually covers, and to possibly reach a consensual definition of blockchain technology. The third point is to analyze the contribution of blockchain technology to Bitcoin, and to get a focus on how blockchain technology could benefit to organization and possibly lead to a decision path for organization to select and design the proper blockchain solution. So the motivation, I go quickly here, is two points. The one is support organization in blockchain adoption, giving a real tool that they can use. The second point is to clarify the different features, mechanism, properties of Bitcoin and blockchain, and to show how they create through their interdependence some key mechanisms. In terms of contribution, that would follow the motivation, meaning one contribution will be more practical, once again for organization in the blockchain technology adoption projects, and the second point will be more academic and clarifying the two technologies, Bitcoin and blockchain, and possibly coming to a definition of blockchain. I will go quick on the resource questions. For the data, so that would be based on the literature review. The first step would be to analyze technologies behind Bitcoin. So review all the fundamental articles before Bitcoin was created. And a second part would be to review the literature since 2014 based on a certain number of keywords to see how the literature covers these different aspects, and how we can, from those two approaches, possibly create a map showing the different features and mechanisms of blockchain and Bitcoin. Still have time, or?
No, that's perfect. You're well on, spot on time.
Okay, so it's a very early stage research.
Yeah.
So I'm very keen to get any comment, questions, or feedback.
Fantastic. So I'll open the floor to questions for Arthur. sorry, for Christoph, if anyone has any questions on the forum. Okay, I suppose I'll kick off, Christoph. So it's very early stage. Have you kind of a leaning toward what type of angle you would like to take in terms of a kind of a method or a research method to analyze the problems you identified there?
Yeah, I think the deep literature review about all the research done on the technologies that have been further used in the Bitcoin protocol, I think is a definitely necessary first step. Actually, the research came from the fact that I read about, I don't know, 80 to 100 articles about blockchain, and mostly focusing on blockchain. And each time blockchain was explained, it was studying from the Bitcoin perspective. And at one point in time, it's a bit confusing to know whether they are still talking about the Bitcoin in itself as a protocol, or if they are moving already on the technology. So the point is to clarify this technology aspect of the Bitcoin protocol, see how the blockchain technology fits and provides support inside. And from there as well, getting a critical perspective about how literature covers blockchain technology features, and to get from those two aspects a kind of synthesis that could lead to a definition of blockchain, which is still missing.
Okay, very good. And I suppose I have one more question. Why yes, the Bitcoin protocol? Have you looked at, let's say, Ethereum or any other type of protocols? Have you juxtaposed those, or are you set on you looking at the Bitcoin protocol?
Yeah, I think I mean, Bitcoin being the first real application on the blockchain, I think is interesting to look at it more in detail. Secondly, the launch of Bitcoin is more than 10 years back, so there's a certain sustainability in the system which make it as well interesting, and might be a sort of a model for further development, including development for enterprises. So I don't want to be too large on the I would say the basic mechanisms, and to see how blockchain contribute to it. Of course, other other solution like Ethereum and others could be interesting, but I mean, I'm afraid that will bring too much information together to get, because as you know, it's very complex to actually get to a sort of definition of what is blockchain. Yeah. And we use blockchain for many different forms, and actually sometimes is questionable whether it is actually blockchain. So I want to be relatively basic and just try to pick here and there and try to build what could be a fair representation of what is blockchain, what are the benefits in particular for enterprises, and get a critical review of how this technology is covered by literature in general. Okay. And there's a lot to cover, as you know, there's a lot of articles coming up.
Yeah, particularly in the last couple of years, the articles have become more, a lot more
every
articles
week,
to review.
Every week is crazy.
Yeah. But thanks a million, Christoph. I suppose we have about 30 seconds left if somebody wants to answer or ask a quick question.
Yeah. Hi, Trevor. I have a simple comment. So last year, I did a literature review that was way more restrictive than looking out for abstract definition. And I ended up with close to 3,800 articles. And that's with a very restrictive research question. I had to pin down my search query to exactly what I was looking for. But again, that's a lot of articles. I looked at your search query, and it seems like you're going to end up with a lot more than 3,800 articles. So
I think there will be a lot of cleaning to do.
Yeah, so
Yeah.
for that, I suggest either make your search query way more restricted than it is right now, because in its current form, it's going to return a lot more articles than you think it would.
Absolutely, I agree with you. Thank you.
That's a great point, Ashish. Thanks a million. Okay, thank you, Christoph.
Thank you very much.
Fantastic. And next up, we have Rangan Zhang, and she will be presenting on the impact of blockchain governance mechanisms on user governance engagement in decentralized online communities. Okay, I'll hand it over, and you can present whenever you're free to do so. Thank you.
Thank you. It's my great pleasure to have opportunity to present here. It's raining heavily outside, so if you hear something weird noise like thunder, don't get scared. It's all right.
No problem at all. Thanks.
Yeah, in Atlanta, it's right, just the thunder and so now I'm going to share my screen. Let me try to.
Hello, just while that's getting set up there, can people hear me? It's Eamon here.
We can hear you, Eamon.
Yeah, I've been tweeting out about our event just to promote it. I think it's fantastic that we're all here together virtually today. And when I think about it, we're coming from all over the world. There are countries, lots of countries represented. It's absolutely fantastic. And if it's okay with everyone, I'd just like to tweet the number of countries and range. So if you wanted to pop into the chat, just the country that you're currently in, we can maybe get some banter going on Twitter just to promote the event and promote what we're doing here, which is really fantastic. And I'd like to commend everybody who's presented so far, and participants, and great questions and engagement. So it's wonderful. Thank you very much, everybody.
Great idea, Eamon. Fantastic. So we're just waiting. Yeah. Oh, you're back again. Brilliant. Fantastic.
I
have a browser can't use the chat function.
Yes. I apologize that it appears some privacy. I think now you can see my screen, right?
Yeah, we can see your screen.
And, excellent. I hope you can see my slides now. All right. I hope. Apologize for the technical issues.
Oh, no problem at all.
Yes. Now we'll start. I hope now you can see the slides, right?
Yeah, we can see you clearly visible now. Thank you.
Thank you. Thank you so much. Good morning or good afternoon, wherever you are. I will introduce myself. I'm Sophia Zhang from Georgia State University. I'm now second-year PhD student. Today, I'm going to present my research on impact of blockchain governance mechanism on user governance engagement. Over the course of human history, all sorts of different institutions have served as the middleman or intermediate to coordinate our social activities or economic activities. Technological institutions such as blockchain has been a transformational and disruptive way that served as a way that eliminates all the trusted third parties with the unprecedented level of decentralizations. Blockchain technology eliminates all the controlling power and decentralized among the participants of the network. And the big question that triggered my interest at the beginning was how are blockchain technology governed so that can at the same time maintain the feature of decentralization, but also have efficiency. Currently, the majority of the blockchain networks are maintained by the central developers and core miners, which is essentially still centrally governed. So in this research project, the specific research question is, how does the configurations of blockchain governance design elements influence the generative and evaluative governance engagement by users in the decentralized online communities? The design elements I will further introduce how we derive from the literature. First, why blockchain governance is unique. Blockchain technology offers unique ways to design novel governance mechanisms for the following three reasons. First, the duality of user identity. Users are not only participants, but also shareholders of the platform. Second, users are empowered to make high-stake decisions. They are able to make changes to the platform architecture and policies. Thirdly, it is a unique, decentralized, collective decision-making process with real-time visibility of the decision process. With these reasons, it is worthwhile to further study the underlying mechanism of blockchain governance. There are two major main parts of blockchain governance: on-chain governance and off-chain governance. Off-chain governance is the current dominant mode in most of the blockchain platforms, which is more like the informal governance. And for on-chain governance, refers to the situation when the rules and decision-making process that have been encoded directly into the underlying infrastructure. And here is an example of the Dash blockchain on-chain governance proposals. As we can see, there are different, how it works is different users can propose their desired changes, and if the change is voted to accept, it will be implemented. Otherwise, it will be declined. And the voting power is determined by the holdings of the cryptocurrency. In the following slides, I'm going to briefly introduce the theoretical background. We draw from literature from IT governance, platform governance, and the user and engagement in the public policy literature. The IT governance indicates that there are three main dimensions in the IT governance: distribution of decision rights, accountability, and incentive alignment. In the platform governance, it presents a paradox of openness, the control of the central platform to ensure the integrity of the platform, and the autonomy reserved for the developers to ensure the generativity. Therefore, additional research is necessary to understand how governance and incentive structure can be best implemented to coordinate the behavior across multiple stakeholders. Also, in the literature in public policy, the user engagement is a complicated phenomenon that individuals formulate meanings and action plans that reflect their desired level of participation. There is also increased consensus in the literature that citizen engagement will lead to improved governance and development outcome. Therefore, we choose user engagement as our dependent variable. Here is the research model. We differentiate two types of governance engagement: generative and evaluative. Generative indicates the proposal generating activity, and evaluative indicates the proposal voting activities. On the left-hand side, we can see the governance mechanism configurations composed of three main dimensions: specifically the decentralization of decision rights, protocol specification of accountability, participation incentives for two major groups, miners, developers, and shareholder users. We adopt a configurational perspective due to the nature of the complexity and interdependence of the blockchain governance. The outcome variable user governance engagement does not singly rely on a single governance design element. And here are the hypothetical configurations. The circle, the large circle indicates, the size of the circle indicates the causal relationship, the strength of the causal relationship. So the larger indicates the stronger causal relation. It indicates the core causal condition, and small circles indicate peripheral causal condition. And the dark indicates the high level of the dimension. The white circle indicates the low level of the each dimensions. For the interest of time, we won't have really time to go through the causal mechanism underneath. Here is the ladder of level of abstraction, which also the operationalization. We will use the number of governance proposals to operationalize the generative governance engagement, and the number of votes, voter turnover rate, ratio of upvote and downvote to operationalize evaluative governance engagement. And there are three major open questions. First, theoretically, that's whether we should increase the number of dimensions in the configuration. Second, empirical, as for the sampling, do we need to further generalize the scope to all the blockchain platforms, or only constrained to blockchain online communities? And whether you have any other potential data source besides the white paper or interview that we can further understand blockchain governance. And that concludes my presentation today. Thank you. I welcome all the suggestions, feedback, questions. Thank you.
Okay, thanks a million for that. And just on time, we have about 3 minutes for questions. Some fascinating research there on blockchain governance mechanisms. So I'll open it to the forum there if anybody has any questions. Okay, I'll just start off with my own questions. Have you, just regards your question there on the sampling, have you any blockchain platforms in mind? Is there anything which you would prefer or that you intend to use?
Sure. There are three main major platforms I'm thinking. One is the Dash platform I just mentioned. It is one of the earliest blockchain platforms that adopted blockchain online on-chain governance, and also another one is GMIT. It is blockchain online communities that recently, I think it's last year, that began to try the on-chain governance mode. So the concern here is with different type of the configurations that to generalize some variance need a wide group of samples, but also at the same time increase the complexity. And so I think it's a sort of a tricky decision in terms of the sampling choice. But yeah, I have some at these three, the BitShare, Dash, and GMIT as my current candidate, but I also welcome other potential choices.
Yeah, I would be interested to see this research, further on down the line, and your results with regard how these platforms, kind of instill, verifiable transparency in the voting mechanism. So it's I'm really interested to see how this research progresses. Does anyone else have possibly one more question we can ask? Okay, just a final question. How far in is this project? How far is to go in terms of the research?
It's pretty new. I just started last semester in Dr. Aaron Rice Theory Development course seminar. So I'm hoping to develop it develop the backend part, the empirical part, as my second year paper. So I still have 2 or 3 years to go in the program. So I'm hoping to within the next year that can to get somewhere.
Fantastic, and thanks again for the presentation. And I'm sure people have questions, further questions, which they will be able to contact you offline. Or if you need any more help within the network here, please do get in touch with everyone if you need further assistance. Thanks a million.
Sure, thank you.
I just wanted to add, looks like a really rigorous and interesting project, and I think it has a lot of potential for being published in really good journals.
Yeah, and I'd like to concur with her that there is huge potential here in terms of looking at this area. Thanks again.
Thank you.
Okay, so next up we have Raghava, and with a paper or workshop paper entitled Blockchain Technology for Product Authentication and Sustainability.
Thank you, Trevor. Thomas Jensen, our colleague, will present the presentation.
Oh, fantastic.
Thomas, you are there, right?
Yeah, thank you very much. Trevor, will you share the slides, or should I?
You can share the slides if that's okay there. You'll probably have better control over them.
No, I don't have. So that's the issue. I tried to load them before, but they didn't load.
Okay, so let me just see here.
I'll try again. So I have to get it all. So I don't know why I'm not allowed to load it. Now I see the file type is not allowed. I'll take one second.
I can load it here if you need me to load it.
Yeah, I think the easiest thing would be just to do the screen sharing.
No, it's fine if you load it. It's that's
why. So I'm gonna load it here. Sorry, now let me see. Screen 2. Okay, can you see your slides here?
Not yet.
Yes, I can see it.
This is not my slide.
Aren't these your slides? Oh, sorry. Hold on a minute now. Start presenting. Let's see.
I'll just try again. See if it comes up.
Thomas, maybe try again. Otherwise, I can also.
I'm trying again. I'm trying again. I just shared the. It's loading up again now. Now I've got it allowed. So.
Oh, I have it here now, so I can bring it up again. Okay. Get rid of that. And share screen. Okay, can you see your slides there?
Yes.
Yes, now we can see it. Thank you very much. Mine is still hanging on the slide. Thank you.
Yeah, you could just tell me to go to the next slide. Thank you.
Yeah, sure. Thank you for letting us presenting. We are already presenting blockchain technology for authentication, but really we are also presenting Internet of Things technology because we are trying to combine those two. And why are we doing that? Because we have seen that blockchain technology have an issue to produce events to capture the data on the blockchain. And we think Internet of Things could automate this generation of events for the blockchains. But I will elaborate that as we go. We're a team of 4 people presenting from Copenhagen Business School. We're on a research project funded by external funding. So yeah, that's the current stage. Next slide. So the problem I will explain now is one of 20 use. It's product authentication. You bought an expensive laptop in your other product. Is it real or is it fake? That is the question we'll try to address. But it could also be close. textiles for babies. You want it to be organic. Is it really organic or what? It could be fair trade. There's many other questions you could raise about your products you buy. The Internet of Things is easy to implement in the lab because it has electricity or space for a device. In case of the textile, there's no space, so it's one of our challenges. Next slide. Yeah, we have done a literature review about blockchain and Internet of Things technology. We found some literature, but if you have some more, please inform us and help us. We have, for example, Florian that have used blockchain and Internet of Things for food traceability. We have a lot of discussions that goes out in a panel every conference, and Sim is good to report from them. It's on the right side. So it's just some examples of literature. If you have some more, please help us and raise. Next slide. So the use case we're talking about, or use cases, they run from the supplier side and all the way to the consumer side, the producer and the retailer in between. So the supplier, he will is an organization that will produce organic cotton, for example, for the textile or for the coats. And they will have issued certificates that this is organic product, for example. Then the producer, he will add a barcode or QR code and so on. So he'll work with some authentication devices, and it could also be IoT devices that he'll attach. And by those, we can then trace the product in the supply chain and thereby increase the traceability. The digital information that we found out will be spread around on those different organizations. And here's some example of the different information you can see. Next slide. So we have used action design research for research, and we have started with one prototype that will then be elaborated into more models involving more and more of the organizations you saw, but also we involve more and more organizations. So we are starting with a few companies that will later grow to 12 companies, and we'll add 25 more companies and 50 more. In total, 83 companies is what we have promised to build the prototypes for and pilot it. So that's our research methodology. Next slide. So the conceptual framework we're working on is taking what you saw in the use case diagram before. It have on the left side, it have the physical world, the physical product that have some authentication device attached to it. Could also be the IoT device. Then on the right side, and that exists today to a large extent. And there will be various organizations that are involved in that, but they're detached from the product, the physical product. And we're adding that we have a digital information in a stored on the right-hand side. So we have the virtual information, and that's the way we hope to strengthen the product authentication, that we can combine the blockchain technology on the right hand with the physical products on the left hand. And the way we want to build it is on next slide, or we are building it right now, the prototype. So here's a simple first use case. The consumer wants to buy a sofa or coach, and then he can go to a website and scan the code, and thereby he get checked on the blockchain node that this is it gets a result back that this is an authentic product. I don't know if my co-authors want to add anything to this.
Yeah, if we have time, and we also think in terms of the product, what kind of data we store on the product, right? We can see that we have public, private, and protected data, And to be compliant with compliance with the GDPR and other kinds of things, we store some information on the blockchain, but rest of the information will still be inside the company portals, which will be authenticated using hash pointers, and then maybe available to the consumers and who are the stakeholders.
Last slide. Thank you. So please come with some feedback, comments, and relevant literature to us. So.
Okay, thanks a million for that fantastic presentation. We have about 5 minutes for questions, so I'll open it up to the audience. If anybody has any questions about that fantastic research.
Yeah, hello, this is Horst speaking again. What kind of solution are you using? Did you mention this in the presentation?
No.
We are using Hyperledger Fabric. So the current prototype development is currently going on. And so the reason for using the Hyperledger Fabric is that we want to use some kind of protected blockchain where the companies from design indices, they can participate, and all other relevant stakeholders, they can participate. We considered going with Ethereum, but we don't want to bind to the common Ethereum infrastructure. So that is one of the reasons we use Hyperledger Logic, and then we are building our own prototypes on that.
Yeah, I guess that's a very logical choice. I just wanted to ask you about your experience with Hyperledger Fabric. Was it straightforward so far?
No, it's quite a nightmare. We have been struggling for a few months, but yeah, we have Somnath is a Linux developer. He's also experienced, but the biggest main problem is the open source technologies and a lot of politics around it. So we are not using the latest version, but we are using some previous versions and building our own code on top of it to make it work. But it's a very, very complicated task.
Yeah, because that's what I heard from other sides. The theory sounds nice, but the implementation is not easy at all.
I have one question, and first of all, thank you for this excellent presentation. So I'm Ulrike and part of the NutriSafe team. And so I'm very interested in your use case about the organic produce. Could you explore and explain it a little bit more in detail, please?
Yes, I could. So many of the manufacturers and producers, they are very concerned to prove that they have used sustainable product in components. For example, that the wood they use for the furnitures, it's sustainable, and from which forest is from. The same goes for the cotton or the silk. They want to trace that all the way, and they pay a high fee today for certificates where audit company will go out and audit it. And we hope to, by posting it on the blockchain, that this cost could be less, you could say. We also have one that is plastic from the oceans. So he harvests plastic from the oceans, and then it's recycled and goes into furnitures as well.
Okay, thank you. So in our case, it was sort of an issue that organic products, they grow basically along the supply chain, and nobody knows where the organic things come from. So there's this example of organic grain and wheat in the US, where you know the quantity that is being harvested and more is being sold as organic. Can you do such an analysis as well?
It's a big issue if that is possible, because then you are making this big brother watching you, because you are taking all the data and sum them up. So we doubt that is a way forward, but instead we want to be enabled to trace each batch of organic cotton, for example, and thereby we can, if we get them more and more on, we can then say, okay, where is the batch so like the Bitcoin. So I think the Bitcoin, the biggest issue is the double spending, and blockchain trying to solve that, and it's the same with the double use of the organic food or cotton in our case.
Thank you.
Okay, thank you, gentlemen. Thank you, Thomas and co-authors, for that fantastic presentation. And once again, if there's further questions, I think we can get in contact offline. And thanks again for that presentation.
Thank you
okay,
for making
we're
it possible.
Cheers. Thank you, guys. We're bang on time. We have 2 presentations left. Next up, I'm delighted to present Erla Malloy and Mafada Santos. It's fantastic, as there are 2 students on our blockchain technology online course here in the Galway Mayo Institute of Technology, and they're presenting some research called A System for Understanding Quantum Vulnerable Blockchains for Smart Healthcare. So it's going to be a first introduction to looking at combining quantum computing and blockchains, and so we look forward to see the presentation. Okay, thank you. Okay, we can see the presentation, Erla. Can you hear us, or? I don't think you have your microphone on. Yeah, your microphone should be on now.
Can you hear?
Hello. Yeah, can hear you, Erla.
Okay, sorry, I'll present out. Yeah, back to my screen. All right, so today we're going to present is a new system we developed as part of our discovery into actually blockchain as part of the course. And as part of this, we'll also provide a solution, a business case for how this solution can be adopted for the development of a smart healthcare application. So firstly, we'd like to introduce ourselves. I'm Erla Malloy. I've graduated from DCU a long time ago. I'm a software architect with over 20 years actually in the experience. Currently work with a payments company called Planet Payments. And I'm currently doing, as Trevor mentioned, the blockchain course in GMIT.
Hi, my name is Mafalda, and I have a mixed background in terms of academia and working in industry. I'm also a student with Jarle in the blockchain at GMIT, and I'm very interested in the applications of machine learning, blockchain, and quantum computing to smart healthcare and genomics. So we can move to the other slide. So our motivations are to understand what are the blockchain security vulnerability to quantum attacks and the applications to healthcare. So moving to the next slide. So to understand smart healthcare, it has come to life with application of technology to healthcare through the Internet of medical things, big data, cloud computing. And moving to the next slide. Technology brings healthcare from a curing concept to a preventive concept by taking advantage of all the data produced and feeding it into machine learning algorithms. And still, with the current traditional computer power, this data is still prone to fraud, identity theft, and cyber attacks. Moving on to the next slide. So blockchain plays a key role in this area in terms of being decentralized, distributed, immutable, and transparent. And it also provides security by encrypting the health data and hashing functions. However, with future quantum attacks, blockchain actually will be defeated. So moving on to the next slide. So there are 2 factors to security in blockchain: the asymmetric encryption for authenticating the transactions and the hash functions for linking blocks in the chain. and generating digital signatures. So the most used public key encrypted systems, such as the elliptic curve digital signature, can be broken by the Shor's algorithm. And as well, the quantum computer power can take advantage of Grover's algorithm to speed up the generation of hashes, which will allow for recreating the whole network or replacing blocks in the chain while preserving the integrity. So on to you, Erlen.
Okay, so on a literature review, we found there's 4 particular pillars that where we can talk about blockchain and talk about cryptography and also quantum computing. And to the left, we have blockchain with existing cryptography. Within the existing applications today, there's fundamentally they're insecure and are open to the threats that have just been mentioned actually above. The next grouping, and that's today, the next grouping is a blockchain with quantum resistant algorithms, and that includes IOTA, which uses the Tangle consensus actually algorithm, QRL, quantum resistant ledger. Corda is currently working with quantum resistance algorithms, and Ethereum are also doing work. Ethereum 3.0 will have quantum resistant algorithms implemented. If we go further out to emergent, we look at when the overall field of quantum computing and blockchain, we see that there's there's a certain prototypes which are largely conceptual, which is the logic contract, which uses quantum key distribution for its consensus mechanisms inside it. And further on the chain, further out, the researchers in Victoria have built a quantum blockchain, which is actually, I think hashing is done by moving back in time, which is fairly conceptual. So we're focused on the first part. We're focused on the first 2 pillars, today and tomorrow. So on our research today, so obviously NICTOL have a list of reduced number of candidate algorithms, and the final is due this year, 2020, which are quantum resistant. As mentioned earlier, some of the algorithms, RSA, etc., are literally under threat from this new quantum supremacy, which actually Google proved late last year. From the documentation review, literature review, there seems to be a higher level of risk from the Shor's algorithm, a more limited threat from the Grover's algorithms. Research work is going on the consensus algorithm, but what needs for us to define in the longer term, what is the level of threat? So obviously in terms of adopting, if we find we work as in our organizations, if we will be challenged if we find that we're bringing in a technology that fundamentally has a security risk, which is theoretical or otherwise. So the area that we're focusing on for the demo will be on the technology where we look at the cryptographical elements of blockchain. So what we did as part of our journey, we took the generalized blockchain security model and we identified a number of key aspects, which is digital identity, which is equivalent to our peer permissions network. We have wallets, which is our permissionless like Ethereum, transaction signing, which is available across the board, consensus algorithms. Threats haven't been identified really yet on this, and I've included storage to address, it is important because at some level we will have elements of storage that are at risk from these algorithms. So I'm going to do now, I'm going to load up this and I hope you can all see it. What we've done, we took codified knowledge, and this is an example of knowledge that you see there out in industry, which is and we decided to encode this into an actual RESTful API and make this information available. So there's some great papers that we use, the Cryptography Primitives by Wang, which is Journal of Network Computing. There's also the IEEE Access article, provides detailed tables of efficiencies of the particular algorithms and the relative threats to quantum computing. What we are doing with our solution here is making this available to researchers and building effectively an information system where we can assess the risks associated with risks associated with. So the first thing we have is we've identified security signatures. These are these are actual RESTful APIs built on top of a SQL server. So if I was to say, look at if I challenge BTC, which is challenge blockchain, what it does, it runs in the database in the background, and it comes back and look at the different roles that we outlined above, outlines the algorithm that's actually used, and determines whether these APIs are actually resistant or not. So this is up hosted out of the
Irla, Eamon
Yep.
here. We're not seeing that website now. We're still on your slides.
Okay, sorry.
You want us to? You might have to share that rather than the slideshow.
Yeah.
Yeah, probably you can share the desktop rather than the document.
Yeah, either share the desktop, yeah, and you can switch between the two then if you need to.
Okay. Yeah. So, can you see my desktop?
We can see your PowerPoints, but they're not in a slideshow. So
minimize the PowerPoint and try and just show your browser.
Okay. Do you see my browser now?
Give it a second. Not yet. No. Stop sharing your PowerPoint maybe, and then click on the share button again, and this time choose the browser or your desktop.
Yeah, that we can.
Yeah, we'll give you a second.
Okay, can you see my screen?
Yeah,
no.
We can see it now.
Oh, sorry, I'm running behind on this. So we have a number of RESTful APIs exposed. These actually sit on the SQL database. So this is BTC. What it does, it runs through what we've documented on Bitcoin, scans across the different levels of actually security, and returns back this quantum resistance field to say whether the algorithms in use are quantum actually resistant or not. So this is the goal for the blockchains. We're building this database under the hood to cover, I think at the moment we've about 80 blockchains documented. There is important thing as part of the research findings, an interrelationship between actually all those actually blockchains as well. For example, because of the forking strategies, for example, Dash actually is forked off BTC, so the algorithms are actually shared between the different blockchain and between the different blockchain solutions. So I'm conscious of time, and if we get time at the end, I could come back and I can bring anybody who's interested through the rest of the actual app itself, because I'd like to kind of move on through the rest of the session, if that's okay.
Yeah, thanks, Erla, and thanks, Mafalda, for that fantastic presentation. And that demo looks absolutely incredible. So
I think Mafalda has. Do you want to just?
Well, so we're running out of time, so I'll just the business case we had proposed was to check the Internet of Medical Things to check the vulnerability to quantum attacks. So we chose this business case because the Internet of Medical Things are being widely used. And they could be wearables, but they could also become swollen or even implantations in any part of the body or even in the brain to treat some health problems. And so it's really important that the technology behind everywhere where the data is moving is quantum secured. So this application that we propose will be very important to support the developers to assess the risk to quantum attacks, to understand which algorithms are actually will be able to be used in the Internet of Medical Devices, because these medical devices are very tiny. They have very low computer power. And therefore, not all the algorithms will be able to be used. So this application will help developers to make a proper risk assessment and to determine which algorithms will be quantum proof and will be applicable to this situation. So I suppose Just getting it short, that was our case study.
Okay, that's fantastic. And I suppose we'll open it up for one quick question. If anyone has a quick question in the forum.
I can jump in. So thank you very much for an excellent presentation. So yeah, we also work with IOTA and IoT devices and things like that. So my question is, how long do you think the quantum computing will come into the industry? And then by that time, don't you think the cryptographic algorithm, for example, elliptic and RSA and other kinds of things will make a progress so that they can be quantum resistant, right?
Yeah, I can answer that. That's actually ongoing at the moment. And there's an interesting paper by Chimeris and Limas on the IEEE axis on the progress of those actually algorithms. I think it will happen next 5 years. However, when we get to this point, well, the interesting area is what is our forking strategy? How do we take some of our legacy blockchain systems that we have today and convert them to quantum resistant form? And what risks are there in the background? If we look at the consensus algorithms where we have high powered computing algorithms, what's actually, we have solutions in the market there today are designed, slow down the blockchain, and you could limit the impact of actual grovers themselves. But we want the blockchains of the future to be going extremely fast. So I think the algorithms will get developed, and there's startups developing them. But I also think that the solution to take a quantum vulnerable blockchain and make it quantum resistant presents an actual challenge to blockchains actually exist in the market today.
Thank you so much. Okay. We can connect offline, and then it's once again, thank you for a very interesting one.
Perfect.
Okay.
Thank you. Thank you for the chance.
Thank you very much.
So
thanks
sorry.
For that question. Thanks to Irla and Mafalda.
Eamon here, just with a quick question, if I may.
Yeah, fire ahead, Eamon.
Yeah, so Irla and Mafalda, thank you very much. That was a very interesting presentation. And just one question, I suppose I have. For the very small amount of Bitcoin that I have in my wallet, should I be worried right now?
No, in the short term, we shouldn't actually be worried. But however, once those, it's usually about 5 years, the NIST are, running through this, it'll get standardized the algorithms will get standardized very, very quickly. And most likely the blockchain companies are currently working on this problem. So we could see solutions coming into the market. So they believe it's a problem. We could see solutions coming into the market. So I just think it's what we have today, maybe transferred into quantum resistant ledger, then transferred back to your Bitcoin when you're finished, maybe away.
Okay. Thanks very much, Irla. And I'd just like to say for the record as well that I'm it's a very proud moment for me to hear Irla and Mafalda present there. It's fantastic to see that level of interaction and engagement from them, who are students on our Blockchain for Business course. And Trevor, of course, a commendation to you as well as one of the staff teaching on that program. You should also be proud. It's very good and well done, guys. That was superb. Well done. Thank you.
Yeah, and I just like to echo Eamon's sentiments, and well done, guys. Fantastic. Next up, and finally, but definitely not least, we have Michael. I don't know about you, but the last 3 hours has flown in terms of these very interesting presentations. I've gotten so much for them. And Michael will be presenting on blockchain and supply chain, and very apt at the moment, the impact of COVID-19. So Michael, I will leave it over to you.
Okay, do you see my PowerPoint?
I do indeed.
Yeah, okay, thank you, Trevor, and all the organizers and the participants. It's very early in the morning in California, and I unfortunately had another meeting at 5 a.m. over here, and this ECIS workshop is the second one I'm doing right now. Just yeah, so that's why I was a little late today. And we are all experiencing kind of very peculiar and unusual time for a couple of months. And kind of the interesting the point we all can think about is we've been discussing blockchain. That's one thing. The other thing is we experience our daily lives about breakout of supply chains in many things. Okay, so from this, what can we do? And one of the things I thought about was blockchain is one thing we can discuss, and especially application of blockchain onto supply chain management. Like the German study last year, we discussed about those refugee cases, or some food, the organic or the security type of things. So there are many the supply chain related blockchain issues ongoing right now. And certainly not because of the blockchain, but because of the peculiar situation. This the supply chain has broken, and we experience all the pains. So we can look at these two aspects. One is blockchain. Can blockchain help kind of recovering or enhancing or fixing supply chain? The other thing is, without even considering blockchain, are there any weakness or the weak links in the blockchain in supply chain? Those are things. And the third thing is, as academician, how do we measure those impact if it did break? So how much, or when, and how long type of things, as well as if we fix it down the road, how long? I mean, what is the impact? What is the value? And eventually, in the practical sense, will they, meaning that the industry executives and companies willing to support, willing to invest, willing to adopt those ideas we are going to generate collectively? Okay? So from this perspective, we came up with this several research questions in a draft. What are the current blockchain enablers and inhibitors that reported success challenges in managing supply chain? And in the IS field, we've done a lot of work in the past about IT and strategy alignment. That's one thing. And that's already probably almost 20 years ago and until 15 years ago. And the other thing is, along the line, we talked about the enablers and inhibitors of certain initiatives. Okay, and many of them are basically technology issue. The other ones are business issue. Another one is the human side of the issues. Okay, so typically, I think one of you might have mentioned earlier, that is, if they build, will they come to use? That's another issue in practical sense. So I want to revisit the blockchain use case onto supply chain, and what are the enablers, if there's any report on inhibitors. So that's one question. The other thing is use of blockchain technology during COVID-19. There's, regardless of blockchain, were blockchain being used ever during COVID-19 to help enhance, fix problems? That's another thing. Third one is how do we measure metrics of success as well as the values of the use of blockchain in supply chain. So these are some the motivational and the research questions I present over here. And then what are the reference frames that we can utilize? Certainly supply chain management. And I've been doing research on value creation and value appropriation type of things in general. So this one includes how do we measure those value? Is it possible to measure at what point? That's another thing. Third one is if we focus on commercial companies or even including government agencies, there are going to be certain company organizational objectives, and how do we generate, for example, revenue, or how do we provide intended service that involves business model. Certainly, it seems some of the business models involving many of the retail chains as well as the manufacturing side have to be somehow modified to respond to these unexpected challenges. And thus, It means basically business process management or business process re-engineering or process management. Those are some of the things we need to refer. Okay, then how do you go about this one? We've read a lot of papers from the media side, I mean the articles, and also some of the people in the management science, operations, research, they are doing some optimization model. So they've been doing this optimization measure for a long time. They are great value over here, but I would like to do this from more on the use case as well as survey or the in-depth interview type of things. So let's take a look at some of the challenges to just get a little bit of taste of this. That is operational challenges. We went to a grocery store and price went up. We went to retail department store or some large Walmart type of chains. We couldn't find the tissues. We couldn't find some other just daily need necessary items, right? So operational challenges from a company perspective is, of course, they couldn't sell, but more or less, if you take a look at the entire supply chain or business process or value chain, there's an issue related to material side, especially raw material side. And we know that there's a bullwhip effect. One small change in the tier one just triggers a little bigger one, the next type of things. Okay. Second thing is, especially for the service industry, demand really fluctuates. And there's almost no demand, but manufacturing side soaring demand. Okay, that's another kind of issue we can consider as operational challenges. And workers, okay, they sometimes want to work in some chicken manufacturing companies in the US Midwest. Workers refuse to work because of the safety measure, even for Amazon too, right? As a result of all this, financial institutions and the companies both, cash flow is really behaving very differently. Okay? And could we collaborate? I mean, I mean by stakeholders in this value chain? There are many difficult issues we need to take a look at. Okay? That's typical operational challenges as examples. Next one is planning and data, the problems. Security issue, fraud issue, politics issue, regulation issue, all these things we've read in the major news media. And the last one is safety measures. So not the last one, I would say, one of the examples of the new issues. So planning and data problems present a lot of issues that will probably just reduce the effectiveness of a typical mathematical modeling side. Okay? Next is how supply chain has been behaving during this time. And when we try to survey or when we try to just actually do a more in-depth the study or observation on these companies, there's a difference among industries. One is labor-intensive industry versus very much service or the high-tech intensive industries. So you see that in many of the technology companies in Silicon Valley or West Coast, East Coast, they are doing okay. And even Twitter is will go for 100% work from home type of situation versus some of the labor-intensive industry like a barbershop or beauty parlors. They can't do anything, right? And the large companies, multiple supplier tiers may have different kind of impact as opposed to small, medium-sized companies. And another one is customer-facing industries versus component manufacturing side. That is triggering effect over time. If some companies overseas, just like the next one, impact of outsourcing, couldn't produce because of worker problems or health issues or safety issues, then next high-tech manufacturing devices, they have problems and eventually consumers will face. Okay? And difference among countries, many different countries handle these issues differently, and Asian countries, North America, now there's some issue with South America, and the European countries have different ways of handling this. And time span. So can you manage this one within 2-3 months of time frame? If you open, you can generate the business and follow up. So short-term actions executives can make. However, long-term strategies might be an issue because long-term strategies, most of the cases, they've been utilizing data of the past. So these current issues do not give you enough room or enough goodies for you to predict, forecast, project the future based upon historic data. Then what's going to happen? It's a real disruption, not about the technology disruption, but about, say, this pandemic disruption. So if you cannot use the previous historic data to generate using machine learning, data analytics, business intelligence, what can we do? There must be a different way of doing these things. So those are the considerations of process and speed of changes and the scope and types of tasks and other measures. Okay? So I was trying to come up with some value side, emphasizing the measure, and on the other side, under the name of governance, which we have done on several good papers today, earlier, and how do we change the process? How do we just make it happen? I am not sure whether this governance word is the right one or not. So this is something I want to do, and I welcome feedback, as well as I welcome collaboration from people attending today, or some other people who are interested in. So my first page of my paper, 2-page paper you all received, has my contact information. I welcome, and given the amount of time, I'll open for questions.
Okay, thanks very much, Michael, for that very interesting presentation. And we're bang on time, so we'll open it up to questions from the forum if anyone would like to ask a question.
Okay, I assume you will send me some emails.
I have a question, Michael.
Yeah.
What stage of progress is this research? Is it just at the beginning, and will you be looking at a specific type of supply chain in terms of the impact of value creation or your value framework? Is there a particular context you're going to look at, or a company?
Yeah, thanks, Trevor. The value side I presented last year, and this some follow-up work. This time, come up with just refining the questions, and the major challenge is who are the people who will be able to excited to answer this survey type of things. That part I need, of course, I mean on the theory as well as paper side, in addition to this contact and all these things. Yeah.
Fantastic. I'm currently writing a paper on supply chain resiliency during pandemics, crises, and one aspect I am looking at is the pharmaceutical and the impact of COVID. So I might liaise with yourself and conversate to get your insights also in the future, Michael, if that would be okay to get in touch, because your research is really apt and on point at the moment.
Yeah, I welcome. I mean, Trevor, you've been in this the blockchain this space for a long time, and I really want to just learn from your wisdom. That's great.
Oh, that's great. Thank you, Michael. You've been at the last 2 conferences also, so it's great to see your model there and the way it can orientate and line to something like COVID and explain that in further detail. So it's great, and we hope to see you in Romania over there next year for the next blockchain workshop in ECIS.
Yeah, okay, lovely. Yeah, okay. We miss all those local culture as well as
yes.
academic things, and this is we could be in Africa. Yeah.
Fantastic. And if anyone has any questions.
Michael, this is Theo, and I have a question. Nice to see you.
Hi, how are you? Okay, yeah, please.
I understand the idea of using blockchain in a supply chain setting. The part that I'm trying to understand is the problem that the supply chain experienced during the COVID crisis. It was a problem from a physical standpoint. Blockchain will resolve the digital aspect of the blockchain. It will not help us handle with factories which are closed because of safety and health issues. So I'm curious how you're making the connection between the blockchain and addressing COVID-related issues on a supply chain setting.
Yeah. Theo, your insight is very well kind of heard and accepted. That is one of the challenges I'm having. Can blockchain help kind of the emergent situation of in the supply chain side? That one I'm not very much convinced. Yeah, yet. So that has to be just revisited and refocused, I think. Yeah.
Hello, Michael.
So that's the one. I will contact you. Yeah, Theo. Yeah, from your accounting and blockchain background, I'd like to have your wisdom too.
Hi, Michael. This is Sophia. I'm mentioning following the previous question. I happen to have talked to one practitioner in a major supply chain industry. She mentioned that blockchain, one way blockchain may help addressing current safety concerns is through the transparency or the disintermediation of blockchain features that can reduce the physical contact along the supply chain. In this way, this can be a point that motivates the use of blockchain technology.
Yeah. Okay. Thank you for the insight. At least I see a little bit of light over there.
Sure. It is one of the major company and they are also collaborating on blockchain projects. So I happened to, through my supervisor, that heard that the practitioners see the point of applying blockchain, especially in this special time. So very timely work that I look forward to see the further progress and can somewhat the academics can inform the practitioners in their applications.
Great, thank you, thank you.
Thank you, Sophia. Have we any more questions? Okay, thanks a million for that, Michael. I know you must be tired. So it's been so early in the morning. They're over in LA.
Very unusual Friday. And I have a separate question. That is to Trevor, since because of the meeting that I missed the first part, will the part of the record or the recorded materials be available to review? I'm interested in the first paper, which I completely missed, host Aaron and Martin's paper. Okay.
Fantastic question. Yeah, this whole workshop has been recorded. And as soon as I stop recording, the link will be available here in the Microsoft Teams to view, Michael. So you'll be able to see any component that you might have missed due to your previous meeting.
Thank you. Thank you so much for organizing a great conference.
Well, thanks a million, Mike. Well, that's a wrap. I'll allow Eamon and Theo and Horst to say a few final words. As normal with this conference, it's fantastic. It would have been great to kind of delve deeper in a personal basis over in Marrakesh. I know last year we got great value of 2.5 working days discussing, blockchain research in greater detail. It's great to have Theo on board as well. He had a great workshop as well over in Stockholm. So we hope to see everyone back again in the physical basis over in Romania. As tradition is that we normally take a picture at the end of this workshop. So if anyone wants to just throw on their camera at the end, you don't have to if you don't want to, but we'll get a kind of overview of all the participants at the end here, and it'll be kind of this virtual snapshot of who was there at that time, if everyone's okay.
Is my hair straight, Trevor? I just I got it done this morning. Spent hours in front of the mirror. No, I'd while Trevor's setting up there, he's going to do some kind of screenshot. I guess just like to echo Trevor's comments there. It's fantastic to get together virtually. It'll never replace the physical contact, and I'm sure we will get to meet again soon, and hopefully at the conference next year, if not before. But it was really, really great to get together virtually as well. It's different, but we're keeping the engagement going, and some of the great research that we're doing in the blockchain space. It's brilliant. Sharing is fantastic, and well done. I just want to say thank you to Trevor, because he did a lot of the hard work in actually the logistics side of it, or digital logistics. So well done to Trevor. And that's it from me. Thanks everybody. Have a lovely weekend, and we'll catch you all soon, either online or offline. Okay, thank you.
Thanks a million, Eamon. Hurst, would you like to say anything?
Oh, I just wanted to say the same thing. Thank you very much, Trevor, for doing most of the hard administrative work. And I really hope to see all of you next year in person in Romania. Just before we started this session, Trevor and I were discussing the option of next year maybe doing the workshop in a hybrid way. I'm not sure if this is possible, but we are going to check this out. So that means even if you cannot make it next year in person, then maybe there's a way to tune in via webcam. So we're going to check this out. And thank you all for joining us here. And it was really good to see all these presentations and to talk to you.
Thanks a million, Hurst. And Theo?
There, Theo.
Don't have anything to add. Just hope to see everybody next year in Romania.
Yeah.
Fantastic. Okay, thank you everyone, and I'm cognizant of the fact that we're nearly 4 hours in, so it's Friday and we're at different global time zones. So thanks a million for everyone, and we look forward to keeping this conversation going over the next year. And no doubt you'll see our call for papers around February in 2021. Thank you very much.
Thank you.
Thank you.
Thank you very much. Bye.
Thank you, everybody.
Stay safe, everybody out there. Well done. Thanks, Trevor. Well done. That's fantastic.
Thanks, Eamon, and I'll just stop
you,
the recording now.
Yeah, stop the recording, and we'll get that out to people as well.